A minute.
Hello, everyone. How are we all doing today? Hello, hello, hello,
Hi
hello.
everyone.
Yes.
Hello, Promise.
Hello,
How
Imo. How
you
are you
doing?
doing today?
Let me. I'm fine. And you?
I'm doing great, Imo. I'm doing great. I mean, what an awesome session we are having today as well. I mean, this is really, 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 really awesome. I think, Imo, if I'm not mistaken, this should be our first reinforced recap, right?
Yes, yes. The one we did one early this year, and that
That
was
was
a re-event recap.
re-event
Yeah,
recap, yes.
recap. So, hello audience. I hope you are all doing great today. So, what it's reinvent a kind of recap, reinforced recap. So, we all know that AWS Reinforced event is centered on security, centered around security. Generally, it's a security conference. So, Promise, what do you look to take away from this section today?
I
And
mean, funny enough, the interesting thing is we have amazing speakers lined up for us today. That's the first thing.
all
And
right,
in fact, I've packed my jotter, my notes, my pen, and I'm ready to take down notes and learn from the amazing sessions we are going to be having today. So, Imo, um, we have been
yeah.
doing quite a number of things in the community lately, right? What do you see this community leading to in terms of security? How do you think we can impact more in the community while we deliver these sessions? I'm just picking
All
your
right.
brain
So,
generally to see how we
yeah,
can
we
impact the community.
yeah we are focusing on our goals. We have the mission of driving over 5,000 security enthusiasts, security experts, cloud security experts by the year 2025. So that's
Awesome.
in mind has is what helps us to stay on track. So today's section is going to add to our kind of our mission, what we intend to achieve by the end of 2025, which is to at least have 5,000 people who are well equipped with the cloud security knowledge. So I believe in Ethan because he's from directly from the AWS team, and I
Yeah.
believe the package he has and will unleash them to the audience. So today's section is going to be a kind of information pack section, really handled by the experts. Okay.
Awesome. Awesome. Thank you very much for that, Imo. So before we welcome Sir Elton to the stage, I just want to say hello, everyone. Please, can you comment in the chat screen where you are connecting from? Yes, I see. Hello, Olamileko Noibi. Hello, Daminola Akimbi. Hello, Onyedikachi Sams. How are we all doing today? If you are on the session, just say hello. I'm connecting from Lagos. I'm connecting from Kaduna. We just want to get a feel of where everyone is connecting from. Wow, awesome. Daminola is connecting from Lagos, Nigeria. That is awesome. That is awesome. Oh, Olamilekon, the same thing to Lagos, Nigeria. I think this is really great. Abdul Latif from Ibadan. Imo, do you remember Abdul
Um,
Latif? He's the guy always winning our quizzes.
okay, now I recall. Yeah, I can remember now.
Yes.
Abdul Latif, thank you for joining us today again.
Yes, thank you
I
for
hope
being a consistent
uh,
member of the community.
I hope you are not going to win today's quiz. Allow others to win. uh,
Interesting. I see Ife Olako. If I'm not mistaken, that is Ife Olako should be Samson. Yes. So Samson, thank you for connecting. Yes. I see Amos Emmanuel. Thank you for connecting. Here, hello Amos. Yes. Yes, we see
okay.
you. All right. I think it's about time that we welcome the speaker for this morning to the stage. I mean, Imo has already given us some brief about the speaker, so I'm just going to give some more details. Sir Elton is a senior AWS solutions architect in from the AWS himself, right? And he has volunteered to come and share his knowledge from the bank of wisdom he has from understanding how AWS works, latest changes happening in AWS, and also to provide us with some information on how we can key into the community, right? So Sir Elton is going to be giving us some wonderful session today. So if you don't have your pen or your paper, please, I would advise you to pick them up and pay attention. Please note that after the session, we are going to be having a quiz. So please, if you want to win from our prizes, pay attention to the session. And trust me, I know it's going to be interesting. It's going to be interesting. So, I think at this stage, let's bring on Sir Elton to the
Uh,
stage.
yes, yes, yes. All right.
Sir Elton. Okay, good. Hello, Sir Elton. How are you doing today?
Hi, Promise. Hi, Mo. Thank you for having
Hi,
me.
Elton.
I'm doing well. I'm really happy to be here. To be spending the Saturday with you and the rest of
Awesome.
the
Yeah.
West Africa community. Really excited for today.
Yeah.
Awesome.
Thank you for joining us, Ayrton. Thank you for your time because it was your time. You are
Yes.
sacrificing time to be here.
Yes. And this is also our first AWS
Thank you very much.
Inforce recap, right? So we are really, really, what's the word to say, excited about this event. And we look forward to all you have to dish out and give to us today. So at this point, I'm going to be handing the stage over to you, Sayotin. Thank you once more.
Thank you so much, Promise. Let me just share my screen quickly. All right. Hi again, everybody. As mentioned, my name is Alton, and I think Mo and Promise did a very good job at hyping me up and giving a little bit of an intro about myself. But I think would like to touch on that a little bit just to share a bit about my background. I'm a solutions architect at AWS, and I've been with AWS for about 7 years now. And within that time, I've spent time in different teams within AWS, engineering roles, and also looking at some of the security stuff that we do at AWS. So yeah, really had the exposure of quite a lot of areas within AWS, but my expertise lie in the security field. So, Promise mentioned that this is our first ever Reinforce recaps. This is quite a special occasion. It's just quite a special event. Usually we have those reinvent recaps where we just do a highlight of what was announced at reinvent. But yeah, for Reinforce, we are doing things a bit differently. So in today's session, we are going to be having a look at some of the services that were announced during Reinforce, but at the same time, we are going to give a little bit twist to it, right? So we're going to be focusing on a particular topic and looking at how to use those services to achieve, certain things or to achieve certain security objectives within AWS. So just a brief overview of what Reinforce is all about. It's basically a security conference where we have our customers, we have our partners coming together and really spending a couple of days in a central location where we have AWS speakers and also AWS partners that share the security knowledge with customers and share best practices and also share security trends, right? Security is quite an important topic. And I think, looking at how fast or the pace of technology and innovation that, we currently live in right now, it's always important to stay in touch with, what's out there in terms of security best practices. So this year's Reinforce was hosted in Anaheim, in California. And we had about 6,000 registrations and we had about 200 breakout sessions together with workshops. So how it works is that pretty similar to reInvent. We have a couple of tracks. For Reinforce, obviously, we're focusing on security. So we had tracks in the identity space, infrastructure security, compliance, and many other areas that are obviously relevant for security. All right, and if you are interested in Reinforce, if this is the first time you are hearing about Reinforce, we'll definitely be sharing the slide deck with you. There's some information that you can read up on, and if you would like to attend Reinforce, those links can pretty much give you the information that you need on how you can start your journey when it comes to attending Reinforce for next year. All right, so this is the topic for today. So we're going to have a look at how to build zero architectures on AWS. As mentioned, there's a couple of services that we'll be looking at. We're going to have a look at how to use those services to achieve a zero trust architecture on AWS. So this is the agenda for today. Just going to spend a couple of minutes just covering on the different topics or the different sort of subtopics. And we're going to start by looking at the concept of zero trust. We're going to look at how we at AWS think about zero trust and some of the guiding principles from an AWS perspective that we think our customers should be thinking about or looking at when they're starting the zero trust journey on AWS. We're also going to have a look at some practical examples on how we at AWS have been implementing zero trust principles. And we'll then wrap up the session by having a look at those particular services that you can use to build your zero trust architectures on AWS. All right. So without wasting any time, I think this is the big question, right? So what is zero trust? So what I want to start with, right, is that the best way to explain the concept sometimes is to look at a real life example, right? And what you see on the screen is a picture of a museum, right? It's a very famous museum in France. And I just want to spend some time just talking about a museum, right? And I think we will connect to how it relates to zero trust, right? Towards the end. But essentially, when you think about a museum, right, we have expensive art inside the museum, and the main idea is that we want to let people to enjoy the art. We want to let people come into the museum, look at the art. We don't want to lock it away, but we want to allow people to enjoy, to walk in and see the art, right? So a museum is typically a building. It has walls, windows, and doors. So these serve as security controls, right? And in addition to that, if you go inside a museum, what you will have to do is you have to go through some sort of security, right? Or security clearance as you go in, right? And once you're cleared, you can now go inside the museum and enjoy the art. But the security controls don't stop there, right? Inside the museum, there's ropes and glass protecting the expensive art. And you also have some security personnel inside. We also have some surveillance controls and alarm systems. So if you get too close to the art, either an alarm will be triggered or the security personnel will come and they will deal with you. So going back to the main aim, right, of the goal for a museum, we want to let people come in and enjoy the art. However, we want to make sure that the art is protected. So instead of implementing just one security control, we implement a few controls to ensure that we have done enough to protect the expensive art. So this is, a good example of, how Zero Trust works when it comes to, building applications. You are not just looking at one control, right? You're looking at other controls, different controls that you can use together, right, to make sure that you're maintaining a very high bar when it comes to security, but at the same time, you're allowing your users, right, to access your applications with ease. So this is the official definition of Zero Trust. So it's a security model that focuses on helping you as a customer or as a client to implement security controls for your resources. So traditionally, security controls have always been network centric. If you had, your firewall, around your assets, typically that would have been enough, right? But Zero Trust, takes a different look, right, into the entire thing. It doesn't just focus on, your network controls. It's about more than that. It's about protecting your resources through network controls. But what else is there, right? What other controls can we implement to improve our overall security? And that is what Zero Trust is all about. And we're going to have a look at how we at AWS, right? We think about Zero Trust and how you can go on about implementing Zero Trust for your AWS workloads. So the first thing that I want to get into, right, when it comes to Zero Trust, right? So at AWS we learn a lot from our mistakes, and we also get strive to get feedback from our customers, right? And learning from our mistakes and getting that customer feedback is crucially important for us, because it allows us to be better. It allows us to build services that matter, to our customers. And also our lived experiences as well contribute a lot, right, to how we're going about building things for our customers. So these are some of the guiding principles that we sort of learned along the way in our journey when it came to implementing Zero Trust. And of course we share those with our customers as principles to consider and to think about when they start their own journey, so they don't repeat the same mistakes. So the first guiding principle I want to talk about is avoiding a binary choice, right? So as mentioned, implementing network controls, traditionally that was enough, right? You had a firewall around your data assets and you were sorted, right? You could filter traffic, allow certain traffic from specific sources, and block other traffic if it didn't come from expected sources. But again, technology has advanced, and attackers always find new ways to exploit your digital assets. Simply implementing firewalls to filter traffic isn't enough anymore. And this has led to a very interesting conversation happening in the industry at the moment. It's actually been a long, conversation happening, and I'm pretty sure most of you have heard, this phrase that the network perimeter is dead. So at AWS, we don't think investing, in your network perimeter is a wasted effort. We believe that it's still important. As a matter of fact, most organizations are still looking into investing more into the network perimeter, hiring networking specialists, and also training our people in this area to ensure that the network perimeter is built to meet the security standards. This is a very important aspect when it comes to security, and we still believe that it's important for our customers to consider. But when it comes to Zero Trust, right, is a guiding principle. you start thinking about zero trust, it shouldn't just be about the network perimeter, but we encourage our customers, right, to think about identity-centric controls as well, right? So this would be in addition to your current networking controls. So the idea is that you want to implement both controls, identity-centric controls and network-centric controls, and have them work together, right, to ensure that you're meeting your security standards. So this is essentially how we look at zero trust is at AWS. We don't encourage the customers to obviously just think about one control, but it's not just about one control, right? It's about looking at other controls that you can use together, right, to ensure that you are implementing the best security controls for the identified risks to your workloads on AWS. Now, another guiding principle that I want to talk about is the use case, right? When building zero trust or when building for zero trust, it's important to focus on your use case. So we'll look at these in a bit more detail in the next coming slides. But the main idea here is that you want to work backwards from the use case. You want to work backwards from the problem, right? Because the security consideration, the security controls that you implement are going to be different. So it's important to work backwards from the use case. So what you see on the slide is, some of the common use cases that you find in today's IT industry. We've got machine-to-machine communication. An example here would be microservices talking to each other, right? Or talking to an API. So that's one of the use cases that you would first have to think about the risks, right? That an attacker could exploit, and then work backwards from that, right? And look at implementing your zero trust controls to address those identified risks. You then have human to application, which is also another common use case. We build applications that humans interact with a lot, mobile apps, web applications, right? Here again, right, security considerations and expectation points will look different, right? So it's important to understand these use cases and work backwards and address the specific risks for this, for these particular use cases. As mentioned, we're going to have a look at these different types of use cases in the next coming slides. So we'll look at some of the services that you can use to address specific risks, and obviously aligning with the zero trust framework or model. And that pretty much ties in nicely with the third guiding principle that I want to touch on, and that is one size doesn't fit all. So we see this a lot with some customers, especially starting out in the cloud adoption journey, implementing the same controls across their workloads on AWS, right? Of course, this can create problems, right? You have applications that are business critical. There are others that are not as business critical. So when it comes to implementing your security controls, you would of course look at hardened security controls for your critical your business critical applications, but the ones that are non-business critical, so this could be applications in your test environment, right? So security controls will look slightly different there, right? They don't have to be as hardened, right? But of course, that will depend on your business and security requirements. But the main idea here is that one size doesn't fit all, right? Security controls will be different, right? Per use case or per application. And the main idea here is that zero trust is a journey, and it's always important to identify your critical points first, then you work backwards from that. All right, so up until this point, we've covered how we at AWS, right, think about zero trust and some of the guiding principles that you can use to implement zero trust in your workloads. What we're gonna have a look at next is just a couple of examples from an AWS perspective, right, on how we actually implement zero trust. And the first one I want to talk about is basically how you as a customer interact with with the AWS platform, right? So when we built AWS platform, we built it with zero trust. We built it with security in mind. So in this example, you've got users that are connecting to AWS, and they connect that via the public internet, right? So from a zero trust perspective, you've got the network path, supported or protected by TLS. We see this encrypts communication between yourself and an AWS. So from a networking perspective, you are pretty much sorted there, right? But remember, network controls alone are not enough, right? So in addition to that, AWS requires that every request that is sent to AWS, it must be, it must be signed with what we call a SigV4 signature. So a SigV4 signature is made up of your AWS credentials. So these are your access key and secret key, and also other information that is used to basically generate a hash, and that hash is then attached to each request as you're interacting with AWS. So when the request reaches AWS, what happens is that the AWS platform using AWS IAM would then validate the signature, right? And if the signature is successfully validated, the request is allowed. So for example, if you are trying to upload an object onto an S3 bucket, that request would be accompanied by a SigV4 signature. Before the object is uploaded onto the S3 bucket, what would happen is that IAM would then verify that signature. And if successful, that request will then be able to upload the object onto S3. So again, we're looking at both network centric controls as well as identity centric controls to provide zero trust. So let's have a look at another example. So in this example, we are going to have a look at how auto scaling happens on AWS. So the process of auto scaling on AWS follows zero trust principles. So it all starts with your account, right? You've got a bunch of EC2 instances running in your account, and you've configured an auto scaling group, right? So auto scaling would increase and decrease capacity depending on your configuration, right? And how it works is that in order for auto scaling to increase or decrease your compute resources, it all starts with an alarm that you configure. So what happens is that if this alarm is triggered, right, and again, right, there's something that you configure. It could be that if you can set a rule that if your EC2 instances are using 70% of CPU, right, you want to make sure that you scale up, right, and launch more instances. You can set up an alarm for that. And once that alarm is triggered, what happens is that the alarm in turn triggers the auto scaling service. So the auto scaling service is, we say, a managed service managed by AWS. It runs in its own private production account that you don't have access to. So auto scaling would then look at your account and see how obviously it can increase your compute resources. And how it does that is that it assumes an IAM role, right? It assumes an IAM role in your account because obviously it needs to increase or decrease compute resources on your behalf, right? So it assumes an IAM role in your account, and then it uses that IAM role to communicate with Amazon EC2. So it communicates with the EC2 endpoint. So this is where the EC2 service lives, again, a production private AWS account that we manage. And to communicate with the EC2 endpoint, of course, we are using SigV4 signature again. And internally, right, this obviously happens internally. We've got network also controls to ensure that from a networking perspective, we are protecting new resources. So what happens is that the EC2 endpoint will get the request, and as soon as it gets the request, first thing it does is it needs to validate the signature attached to the request. It talks to AWS IAM, and once validation is successful, then what happens is that the EC2 endpoint then goes ahead and deploys more compute resources in your AWS account. So that's another example of how we've been using zero trust in the AWS platform. we started using or implementing zero trust principles before they became, popular, to say. The AWS platform, right, is security is, job zero for us. We always build with security in mind. So just wanted to cover, those two examples just to show you how, from an AWS perspective, right, from, the AWS sort of inner workings of the cloud, right, how we implement, some of these principles, looking at some of the, features that you interact with on a daily basis. All right, so now let's have a look at how to actually achieve zero trust, right? Again, we spoke about the different use cases. We spoke about working backwards from that, right? We'll now see, right, the different use cases and the choices that we make when it comes to using the different, AWS services, right? As mentioned, working from backwards from use case is important. It enables you to pretty much choose the right security control, thereby choosing the right AWS service to address, a particular risk. So we're going to have a look at some of those use cases and see how those apply when it comes to, building for zero trust on AWS. So on this slide, we have a machine-to-machine communication use case. So for the purpose of this example, right, let's imagine that we have an employee directory app, right? This application is hosted on AWS. It's pretty much made up of 3 layers. It's a 3-tier web application. We've got an application load balancer. We've got our web servers, and we also have our database on AWS, right? So let's imagine that this application was running on premise, and we've just done a lift and shift, and we just moved it to AWS. So we've got this application, a 3-tier application running on AWS. Now let's have a look at how we can implement zero trust principles for this particular application. So the first thing that we want to do, right, is we want to, take care of our, network controls, right? And for that, we're going to have a look at using security groups. So security groups ensure that each of the different, layers of our application is protected. So what we do here is that obviously following, least privilege, principles, right, which is also an important part of, achieving zero trust in AWS. We'll make sure that our web service can only accept traffic from our application load balancer, and we'll do the same for the database, right? The database can only accept traffic from our web servers, right? So the security groups help us when it comes to such controls, right? We're able to go that granular and just ensure that we're allowing specific traffic into the different components of our application. Of course, as we need to scale, as the application grows, as we obviously hire more people, right, to our company, people are using our employee directory app quite a lot and quite often. We have to think about scaling. We have to think about growth. We add more instances, we add more servers. So those instances of servers that we add into the application would also be part of that security group. So another thing I want to highlight about security groups is that they really help when it comes to building a boundary, right? So for example, let's say the second application that we migrated onto AWS is the IT help desk, right? So as you can see in the slide, we also define security groups around the different components of that application, right? And through security groups, right, again, following less privilege principles, right, we're able to ensure that if these two applications don't need to be aware of each other, we're able to do just that, right? There's no need for these applications to talk to each other if there isn't a need, right? Security groups also help with things like that. All right, so we've moved these two applications on AWS. And as mentioned, we're hiring more people, usage is going up, people are using the app more and more. And as like any other migration, sort of project, right? When you do a lift and shift, the main idea is to naturally look at how to modernize and improve and build upon the application, right? So let's start doing that. So we've got a bunch of microservices that are running outside of the account that the application is running in. And obviously, as we modernize, right, the employee directory app would need to consume those different microservices, right? So, I mean, that's something that can be, communication can be done, right, without any issues, right? But again, we are trying to think about, zero trust. We try to think about how do we ensure that this application we are, still modernizing, right? But at the same time, we are, ensuring that we are still meeting our high bar for security, right? So, in a situation like that, right, this is where AWS Private Link, comes in. So how this works is that you pretty much have what we call a network interface, and that network interface, again, you can use a security group. So that security group pretty much would then control access to the private link, right? Obviously, that's important. We don't want anything within our space or within our VPC to talk to the microservices unless it really needs to. So we implement security groups around or for that network interface just to ensure that only the employee directory app is able to talk to the microservices. Of course, right? There's other options. We can also implement mutual TLS and also auth2 for those identity centric controls for our application. All right, so the same would happen when it comes to the IT help desk application. Also it might need to talk to a third party, right? Then would use the very pretty much the same thing, right? Using AWS Private Link to allow that communication between our VPC and other third parties. So essentially, AWS Private Link is a very powerful tool. It's a very powerful service. Allows for that communication between applications hosted in different AWS accounts and different VPCs. So again, it becomes central when it comes to implementing and building for zero trust on AWS. All right, so we're still modernizing, and our next step is we want to look at the more sort of modern technologies. So we want to replace our relational database, right, with a NoSQL database. So for that, we're going to have a look at using DynamoDB. So because DynamoDB is a public service, it exists in the public domain of AWS. So we've got two options here to connect our application to the database. The first option is that we can implement a public route via the internet so that the application is able to communicate with DynamoDB. Of course, this is an internal app. If there isn't a need for that, right, then we don't need to do that. And obviously, it's not the most secure option, right? The other option is we can use a VPC endpoint, right? So a VPC endpoint is also a very powerful tool. So what this does is it connects your resources within your VPC with the AWS sort of public address space, right? So services such as DynamoDB, services such as SQS, Amazon S3. So it just creates the connection between your VPC with those services. And obviously, it uses the AWS Backbone network to securely create that communication channel to ensure that you don't have to go through the public internet in order to communicate with those services. Again, right, from a security perspective, from a security control perspective, VPC endpoint is also a very powerful tool when it comes to that. It allows us to build policies, right? These are called VPC endpoint policies. With these VPC policies, we can control, right? We can access the DynamoDB table, right? Obviously, that's important, right? Again, we don't just want anybody or any application interacting with that DynamoDB table. So we make sure that we lock it down to only the applications that need to be communicating with DynamoDB. All right, again, right? We still have our microservices, and for that also, will be using a VPC endpoint to communicate with the different services that are deployed in different accounts. So one thing that I want to highlight, and I think is something that you might be thinking about, what's the difference between private link and VPC endpoint? So if you ever look at here, right, as I mentioned, VPC endpoint, it directly connects you to a particular service, right? But with private link, right, private link just creates a path between different VPCs and different accounts, right? So if you are, for example, wanting to connect your application with an application load balancer, right, in a different account, a different VPC, right, you can use private link for that, right? But if the service that you want to interact with is an AWS service that is obviously supported as a VPC endpoint, then you would definitely use a VPC endpoint. Again, looking at our identity-centric controls, CB4 signature as well, and also we can have a look at a mutual TLS as well, because in this particular case, the endpoint that we are communicating with is Amazon API Gateway. Again, our IT help desk is still there. There isn't the need for it to be communicating with the microservices that our employee directory app is communicating with. So we make sure that there's no path for that, right? But obviously in the previous slide, it had it owned sort of third-party service that it was talking to. For that situation, obviously would then create a path for it to talk to that particular third party. So when it comes to machine communication, right, that is an example, right, on how you can go about using the different AWS services to achieve zero trust principles. So I think just looking at that architecture, right, as as we continue to modernize and as continue to build more features and services, right, it can be a bit tricky. It can be a bit messy, right? You are looking at a situation where you can end up with something like this, right? Excuse me. So what you see on the slide is you've got a bunch of VPCs and accounts and different services, right? All these need to communicate with each other. This is something that can happen. This is something that to manage, it can be a nightmare. And also it can be, it can introduce a lot of human error. And we all know that, with human error, right, it can be very costly, right? For example, you can, by mistake, open up, one of the components to the public internet, right? Then what happens then, right? Potential attacker could, exploit that, and through that, they have an entry, an entryway into, your AWS resources. So you want to make sure that you avoid that, right? But this is a reality for, most customers. And, again, at AWS, we are always, talking to our customers to get feedback to understand how we can do things better, right? And, some of the feedback that we got from our customers was that, zero trust is great. And, we understand how to implement zero trust. We understand how to use the different services to implement zero trust. But this is a problem, right? Like what you see on the screen, can be a problem. Maintaining and managing the different components as you build and you scale your applications, right? It can be a bit tedious, and as mentioned, it introduces, a lot of mistakes. So we took that and we went to the drawing board and we thought about how we could improve that for our customers. And that is how Amazon VPC Lattice was born. And this service is pretty much there to, make life a little bit easier for our customers. This service was announced last year at reInvent, and it went generally available, I believe, this year at Inforce. I might be wrong, but it might have been before that. But it basically just helps our customers to centrally manage communication and connections from your application with the different microservices. And we're going to have a look at how this mess that we see here, right, how this can be simplified using Amazon VPC Lattice. So we're going to have a look at that in the next slide. But key takeaway here, right, is that VPC Lattice becomes super important when it comes to applying those granular access controls for zero trust. And we're going to have a look at how that works in the next slide. All right, so let's look at how Amazon VPC Lattice can really transform how we manage, the different components in our application, right? So let's suppose that you've got, obviously we know that we'll have, as we build and modernize, we'll have, different microservices. So for our employee directory app, let's say we've got a direct report microservice, which shows, if you're looking up or stalking someone, it shows the different, people that report to that person. Also, location as well, right? So we'll have a microservice for that. We'll also have a microservice for our awards, right? Right. So we'll have our employee directory app. Obviously, looking at the 2 slides back, we saw the mess. We saw how it can get really complicated very easily. We want to solve that, right? And that's where Amazon VPC Lattice comes in. So when working with Amazon VPC Lattice, there is a concept called target groups. So target groups are very similar to load balancer target groups. So these are the components that you want to route traffic to, right? So these target groups you'd have to create on Amazon VPC Lattice, or rather expose, so that VPC Lattice is able to route traffic to the different target groups. So we'll register these microservices as target groups when we build our Amazon VPC network service. Another concept that's super important I want to talk about is a concept of a service. So a service is the actual component that it's Amazon VPC. It's an Amazon VPC Lattice construct. It's the service that pretty much is responsible for routing traffic to the different target groups. So we will have services for the awards microservices, and we'll have a service for the direct report microservice, as well as the location microservice, right? And of course, communication with the services themselves in the different microservices. Those also will be protected using a certificate for AWS Certificate Manager. Right, we then have our directory app, VPC Lattice service network. So this is where you deploy your services. So another thing that I wanted to mention about services is that they allow you to build rules, right? So how they determine where to route traffic, right? They basically use those rules, right? So you would deploy a service in a VPC Lattice service network, and our application, our employee directory app, would then in order to access the different microservices, the traffic would then flow from our web application to the Amazon VPC Lattice service network. Again, these service networks, as mentioned, they are deployed within the Lattice service network, or rather, you have to register them, right? So that VPC Lattice is aware of them, and also we have to register our employee directory app, right? So that VPC Lattice knows to expect traffic from it. So Amazon VPC Lattice acts as that middleman that pretty much orchestrates, centrally manages, traffic securely between your employee directory app with the different components of your application. So the traffic would start from our employee directory app. Let's say someone in the company is, stalking someone. So traffic would flow from the application straight to the Amazon VPC Lattice service network. From there, it uses the services. Obviously, these services have rules. So it uses the rules defining these services to determine how to route and direct traffic to the different microservices. So at a high level, right, this is pretty much how it works, right? It makes life a lot easier. I consider myself a very lazy developer. So if there is a service that can come and make life very easy for me, if I don't need to, worry about being intentional and I'm writing specific rules to control traffic and to control connections between the different components when I'm building an application, I personally love this service. It makes life easier, and the nice thing about it is that it's very easy to use. You don't need to be a super advanced, network engineer to be able to use the service. It's very intuitive. It really allows you to just centrally, manage communication and connection between the different components for your application. So at a high level, that's what Amazon VPC Letters does. It's an awesome service. It makes life a lot easier for us. But again, right, we're still thinking about zero trust. We're thinking about security controls, right? So we'll definitely implement our security groups, right? For all the components of our applications, right? The employee directory app will also have its own security groups, similar to all the different components that we have, right? So from a networking, sense, right, we've got our controls implemented. Again, SigV4 signatures, right? These obviously ensure that the requests, as they bounce from one component to the next, they are they come with a hashed signature, right, or a hash attached to the request, to ensure that the requests are coming from trusted sources. So standard identity controls from an AWS perspective, those are implemented. Security groups as well, those are implemented. And again, it makes life a lot more easier, especially with security groups. You will basically centrally manage that on Amazon VPC Letters, right? As opposed to if we were to remove Amazon VPC Letters from the picture, then at each and every component, right, you'd have to have a specific rule allowing the different components. But here, as far as you're concerned, you just have your security groups or your security controls or rules defined within Amazon VPC Letters, and that is pretty much it. So at a high level, right, that is how it works. And obviously, when it comes to zero trust, right, the security groups and SigV4 signature from identity-centric sort of approach, they allow us to be able to achieve our zero trust architecture or model. All right, so I want to zoom out a little bit. I think the previous slide was, had quite a lot of components. I'm sure that you have questions. We will get to that as soon as I'm done with the presentation. But I want to zoom out a little bit, right? So as mentioned, the case that we just looked at was machine-to-machine use case, right? And we covered how you could implement zero trust principles using the different database services, right, to obviously meet your security requirements, right? But what I want us to look at next, right, is the human access element, right? So how do we think about zero trust when humans are involved? So we're going to look at that next. So with the human to application use case, right, the goal is that we want to ensure that our users are able to access the application in a very easy manner, and they're able to access it from anywhere in the world. But of course, we want to make sure that we're maintaining a very high bar when it comes to security. So before we get into how that works or how you could potentially achieve that on AWS, what I want to talk about, right, is it's always good to sort of take a step back, right, and let's have a look at how things are currently, right, before we introduce something new. So traditionally, right, and I use the term traditionally very loosely, right, because some of these patterns are still implemented even today. So we have our employee directory app, right, hosted on AWS, and we've done our bit when it comes to implementing the zero trust principles. So how would you as an employee, right, access this application? So the first pattern that we see is that you would typically access this application from the office, right? And your corporate network would then be connected to AWS, either using VPN or direct connect, right? So VPN is just basically that, right? It's a service that pretty much creates that VPC tunnel between your on-premises corporate network to the AWS cloud. AWS Direct Connect does the same thing, but if you're looking for more bandwidth, more reliable connection speeds, right? That's what you would typically look at. But this is pretty much the standard sort of pattern that we see. Still very popular even today. Most customers use this, right? connecting from the office, either using Direct Connect or VPN to connect to your resources on AWS. Again, we live in the age of remote work, so we have to think about that too, right? So if you're working from home, you typically sort of VPN into your corporate network, authenticate. Then once that's done, using a client VPN, then you're able to access the resources on AWS. So these are the methods or sort of patterns that we see today. And as mentioned, pretty still, popular, right? Like I said, use the term traditional very loosely, but these are the patterns that, are still in use today. So remember, the goal here is that we want to make it easy for our users to access the application. We want to provide a seamless user experience, right? But at the same time, we want to maintain a high security bar, right? Now, VPN can have issues, right? And obviously authenticating, going into the corp network, authenticating and coming back and accessing. So obviously, multiple hops from a user experience perspective, there's opportunity to do that better, right? And we're going to have a look at how to do that, from an AWS perspective. And that is how AWS verified access, comes into play. So this is another service that was announced recently last year at reInvent. Its purpose, right? It's just geared towards, it sits right at the heart of, another debated conversation in the IT industry, right? User experience or security, right? As mentioned, using VPNs, right? That can impact user experience to a certain degree, right? Multiple hops, authenticating with your corp ID, and then from there, accessing, the applications or resources on AWS. That connection might not be, as stable, so it can degrade, that user experience. And AWS verified access, it's pretty much there to help with that, right? To remove the need for VPNs and provide a solution, right, that makes it easy for users to get access to your resources on AWS. But obviously, most importantly, while still maintaining and meeting your security requirements. So let's have a look at how that happens today. So what you see on the slide deck is our employee directory app, and obviously we have different components in our employee directory app, and in order to access this application, right, as mentioned, we want to have users access this application from anywhere in the world. So through the internet, right, you would access the application. If you're working remotely, of course, you'll be using the public internet. Obviously, you'll be using VPN, right, to create that secure tunnel, right? But we're removing that and we're introducing AWS verified access. So how this works is that you would configure this with your corporate identity provider, right? So you would start by authenticating with the identity provider. Depending on the protocol that you're using, you would get either a SAML token or an identity token or an access or some sort of token, right? That you can use and present, right, to verified access, to show that you actually are a trusted identity, right? So you would then use those tokens to access the application on AWS. Of course, the application will go through verified access. So verified access would then validate that token with your corporate identity provider to ensure that you are who you say you are. And if that's successful, then it allows you to access. Now, when it comes to security, right, or security events, context is really important, right? And a really powerful feature that verified access has or uses, right, is that it uses different signals, right, to really inspect or evaluate a request, with enough context, right? So one of the things that it looks at is your device fingerprint, your location. So these are some of the signals, right, that it uses, to ensure that you are who you are as a person, right, to validate your identity, right. For example, if an attacker is by some miracle they manage to get a hold over your identity token or SAML token, obviously they would try to connect to the employee directory app. A verified access would look at the location, would inspect the device fingerprint and things like that, right? And if it detects any anomalies, then it would not allow the request through. So those are some of the signals, security signals that it uses, right, to ensure that the highest level of security is still maintained for your application. Again, it becomes really powerful, right, when it comes to dealing with the human to application aspect of things, right. Implementing your zero trust principles. Again, it also uses policies from IAM to ensure that you are authenticated properly as well. So really, really cool service, a really powerful service. Helps when it comes to improving that user experience, but at the same time making sure that you are maintaining the high bar for security. One of the last topics I want to talk about is authorization, right? This is again a conversation that we've been having with a lot of our customers, right? Especially developers, right? And the feedback that we receive from customers is that building authorization logic, right, is time consuming for developers, right? So not only time consuming, right, but some developers, they actually include that authorization logic within the application itself, and obviously that can have it will have performance implications for the application, right? So our customers have shared that feedback with us that it would be great if they could have a service where that authorization logic is offloaded, right, from the application and also from their hands, right? Excuse me. Developers want to build, right? Developers want to build the latest and the cool stuff, right? You would argue that obviously a modern developer needs to have multiple hats, but at the same time, time and speed is important, right, when building applications. So this is something that at AWS we fully understand, and in the last sort of section for our presentation, we're going to have a look at one of the services that were also recently launched at last year's reInvent. It's also generally available, and this service is called Amazon Verify Permissions. So essentially, how this works is that it takes away that burden. It takes away that authorization logic from developers, and what you pretty much do is you just build policies, right, that would dictate how authorization happens in your application, right? As mentioned, authorization logic can be heavy, right? Can be resource intensive, and obviously you don't want that from a user experience. You want to make sure that on your application you're only doing or processing the things that you need to be processed. And if you can hand over that to a different component, then that's what you want to do. So Amazon Verify Permissions is a service that allows you to build a policy. It uses the CEDA policy engine. So this is a policy engine that we built ourselves. And it pretty much allows you to define or build role-based access controls and attributes-based access controls. So if you have a look at the screen, right, you've got an example of what the policies would look like, right? You're able to build those policies in order to control what needs to happen, right? If a particular user is asking for a particular resource, right, what happens is that that logic or it's run by Amazon Verify Permissions instead of your application. Right? It then does the determining who has access to what. If you come in and you ask for a particular resource, and if you don't match with what is defined in the policy, what happens is that it returns a deny. And from that point onwards, as a user, you're not able to access whatever it is that you're asking for. If it's an allow, right, then obviously you have access to that particular resource. So at a high level, that is pretty much how it works, right? Again, a very very powerful service. Not only does it make life easier for developers in particular, but again, it's going to be important when it comes to implementing those identity-centered controls for zero trust. So how does it work? I did touch on this briefly, but let's imagine that you've got an employee, right, who is looking to perform updates, right, on a record, right, on the database. So obviously they interact with the application, right, and as they are trying to update those records, right, what the application would do is it would communicate with Amazon Verify permissions, right? And ask, hey, this person is asking to, update their record, right? Can they actually use it? Do they have permission to do that? Verify permissions will then do its magic, do the evaluation, looking at the policies that you've defined, the rules that you've defined in the policy, and if that particular employee has access to, update, that particular customer record, Verify permissions would then return a result that, hey, this employee is actually allowed to update the record, allow them to update the record on the database. So that's pretty much how it works. Obviously, without Verify permissions, that logic would either be running on another, component, right? Could be a Lambda function, or could be an EC2 instance, or whatever, right? That fits your particular use case, right? But the idea is that you want to hand that over to a service that is purpose-built for that, so that you don't have to worry about implementing complex rules for authorization. So, in a nutshell, at a high level, that's pretty much how it works. So let's put everything together, right? Going back to our employee directory app, right? Apologies if this architecture is a bit messy and it's a bit unclear to see. We did cover quite a lot of things today, but I'll go through each component. So looking at the human to machine or human to application side of things, right? We have two services that help with that, right? Really helping us to achieve or to implement those zero trust principles. We have Verify permissions, which makes it easy for or rather verified access. The names can be confusing, yes, I know, just got confused there. So you've got verified access, which pretty much makes it easy for your employees to interact with the application in a secure manner. Also, providing the best user experience, right? They can access from anywhere. There's no need to use VPN agents and client agents and things like that. It just really makes life easier for your employees to access your application, again, while maintaining the highest security bar. And of course, on the machine-to-machine, side of things, we have our VPC lattice, simplifying communication and connection between the different components in the application. And again, we have security groups. We've got VPC endpoint policies. We've got Verify permissions, which is obviously another service which provides an additional layer when it comes to identity-centric controls. So putting everything together, this is what we have as the sort of target architecture. Really different services and obviously different security considerations that we had a look at, right, for the different use cases. And I really do hope that in this slide that you're able to take away that main point that I mentioned, that when it comes to implementing those zero trust principles, right, it's important to think about the use case. It's important to think about what you're solving for. It's important to work backwards, right, from the problem in the use case. I hope that it's very clear that for a particular security control, we choose a particular service and the thinking behind that. So yeah, that's pretty much it, right? Again, this is obviously very specific to this application. It's an employee directory app with a bunch of it's basically 3-tier web application, right? Obviously, there's other use cases, right? There's EKS, right, where you have an application that's fully running on EKS. We've got use cases for building a data platform in AWS, right? So obviously there, right, things would look slightly different when it comes to thinking about securing and implementing those principles for those particular applications on AWS. All right, in closing, just want to highlight again, right, the importance of working backwards from the use case, right? Zero trust at the end of the day, right? It's a security model, it's a security framework, right? When working with working with AWS or working with any cloud services provider, right? You're always going to want to use tried and tested frameworks, right? And how you implement the different controls within that framework, right? It'll vary, right, as we've seen, right? But it's really important that the sort of same thinking behind security from on-premise that you have, right? The different ways in which you do things, right? When moving to AWS, it's very important, right, to carry some of that over, because that some of the stuff is very important. Obviously, right, it's a different operating model, right? Moving to cloud is very different to maintaining stuff and building stuff on premise, right? But some of those practices, some of those security practices, right? Building security analysis or security assessments, right? Just to or risk assessment rather, right? Just to understand and identify risks, potential risks that could affect your application, right? And then working backwards from that, right? Looking at the different frameworks that you could use, right? It could be zero trust, right? It could be another framework, right? Or implementing a data perimeter. That's another framework that is very popular as well in the IT industry. So those sort of frameworks, right? You can implement them on AWS, but it's very important that just because you're moving on to AWS, right? Yes, you do get the infrastructure, the benefits of the security that we obviously work on, right? At an infrastructure level, right? But as a customer, right, obviously you have your part to play, right? As a customer, to make sure that you are building for security for your applications, right? So crucially important to think about these things, right? Some of these practices, some of these security practices, you don't need to let them go. Just need to shift them and look at it from a different perspective now that you're on AWS. So yeah, that is pretty much it, right? Always think about the use case, always think about working backwards from the different use cases, because security controls will be different, but ultimately the controls that you implement will be determined by the risks, the potential risks, the problem that you're trying to solve for. All right, that is the end of my session. Thank you for lending me your ears. I've really enjoyed talking about zero trust with everybody. And yeah, I hope you've enjoyed it. I wasn't able to look at the questions coming through in chat. We'll move obviously to that section right now. But again, thank you for making time and listening and lending me your ears. It was a pleasure to talk about the different security controls and just how we think about security from an AWS perspective. Thank you.
Can everyone hear me? Can you hear me?
Yes, I can hear you, Mimi.
Okay. Wow, wow, wow. That was an amazing session by Mr. Elton. I really, really enjoyed everything. Learned so much about directory app, that is the VPC.
Thank you, Mimi. I think we lost you for a bit there. Yeah, I think we lost Mimi.
All right, thank you very much. Thank you very much, Sayotin. This was really, really awesome. I think Mimi was having some issues with her
Yeah.
network. You know,
Hopefully she comes back.
yeah, hopefully she comes back. But I mean, Sayotin, that was a wonderful, wonderful session. I know you couldn't cover all you intended to go through, but still, it was very, very extensive. And at this time, I mean, I guess it's time for us to quiz the audience to know if they were really paying attention, and let's see who is going to win this session. All right, Sayotin, thank you very much once again. It was a pleasure having you on stage. I mean, what can I say? You have graced our very first AWS reinforced session, and we are really, really happy about that. Thank you
Thank you.
once again.
Yeah, thank you, Promise, for the invite. Really enjoyed my time. And I hope that you invite me back again soon.
Sure, sure, definitely, definitely, definitely. Thank you very
So
much.
thank you.
Okay,
Bye.
yeah,
Cheers,
bye
everyone.
bye. Yeah. All right, guys. I mean, thanks to Sir Elton for the awesome session he has just given us. At this point in time, we would like to roll out our quiz session. So, let me know if you were really, really paying attention. I want to know if you were paying attention, right? So, um, I'm gonna be sharing my screen, but This is the quiz link. Just a minute. Let me bring that up. Yes, just a minute, and we will be on that. Yes. Awesome, awesome, awesome. All right, we are up, right? Let me share my screen so you are able to see this. All right. So this is how you get to join the quiz session. Um, Go to ahaslice.com/BUBHURD. Let me paste that in the chat session. Yes, let me paste that in the chat session. Yes, this is the link, guys. Let's go here to connect for the first quiz session for the day. Yes, guys, let's connect to the first quiz session for the day. I mean, I'm not seeing anyone connecting, and I know some people are joined in and logged in. So, what's going on, guys? I've shared with you the link to the quiz. What is going on? Let's connect, connect, connect. Who's going to win this one for us? Yes, 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 guys. Hey, Tunde, welcome, welcome, welcome. I see you're the first in line for this one. Thank you, Tunde. Will you guys allow Tunde to win all of this session today? Oh, I see there's someone called Choose. Interesting choice of name. And I see there is a Psalms. Welcome, welcome, Choose. Welcome, Tunde. Welcome, Psalms. Oh, I see there is an Olix. This guy called Olix. You're a suspect. Your name is very, very familiar. Let's see. Let's see what or if Olix decides to, do like he always does. Who else is joining the quiz, guys? Who else is joining the quiz, guys? Are we just going to let these four people compete? Are we just going to let them compete? Alan Key, you're welcome. Alan Key, you're welcome. You're welcome. Guys, hello, guys. What is going on? Just five of us. All right. In order not to. Oh, okay. I see someone is asking that the link be shared on LinkedIn. Yes, we are actually streaming this to LinkedIn. So, let me see if I can share this on LinkedIn as well so that we have people from the community who are on LinkedIn be able to participate. So, guys, um, I just shared the link on LinkedIn. Um, yes. So I just pasted the link on the comment section of the stream on LinkedIn. Yes, I just pasted the link on the comment section on LinkedIn as well. So I see we have 7 players. All right, in order not to waste so much time, let's start the quiz and then every other person can join in from there. I'm just wondering who is going to win this one. Who is going to win this? All right, I'm starting the quiz. Oh, interesting. All right, guys. So, yes, we are on. We are on. What is the core concept of the zero trust security model? What is the core concept of the zero trust security model? I mean, who is going to win this one? I'm kind of waiting to see if everyone paid attention while Sir Etin was. Oh, everyone has answered. Awesome, awesome, awesome. Okay, let me share the answer. Wow, verify and never trust by default. Awesome, guys. Awesome. You guys are doing wonderfully well. Let's see who is topping the board. Wow, Psalms, Olix, Ames, Tunde, Choose. Psalms, are you confident of yourself? Are you very, very confident that you are going to be winning this session? How confident are you, Psalms? Eh? Ames, I'm seeing your thumbs up. But Samson or Psalms, if you are confident that Olix will not beat you and Ames will not overtake, just give me a thumbs up. Let me see how confident you are. And Olix, let me see if you are confident. Give us a thumbs up if you are going to be able to beat Psalms. All right, on to the next question, guys. Which AWS service is commonly used to manage identity and access within a zero trust framework? Which AWS service is commonly used to manage identity and access within a zero trust framework? Olix, I see your thumbs up. It's like you have answered the question already. Is anyone going to beat Olix? Sams, are you going to maintain your position? What about Ames? What's happening to Ames? Is Ames going to be able to grab this away from Sams? JP, I see you. JP, I see you. Sams, I see you. Awesome. Everyone has answered. So let's show the answer. Awesome. Wow, you guys were really paying attention. Interesting, interesting. AWS Identity and Access Management. Awesome, awesome. So let me see if someone will top Psalms or if Psalms will maintain his position. Let's see. This sounds guy the vex. So Psalms, what's happening? Olix and Ames. Are you just going to be there and allow Psalms to win? It doesn't work that way now. Olix and Ames, choose. Will you surprise me and so let somebody give Sam some kind of fight? Let's see if you are going to topple him or overthrow Psalms. All right, on to the next one, guys. Let's see. On to the next one. What is the primary goal of a zero trust security model in the context of network access? What is the primary goal of a zero trust security model in the context of network access? Who is going to win this one? Who is going to win this one? Is somebody going to beat Sams? Let's go. Is somebody going to beat Olix? Let's go. Who is going to win this one? Let's go. Who is going to win this one? Let's go. Uh-uh. Guys, Hazan Samuel, I've not been seeing you on the board though. Looks like everyone has answered, so let's show the answer. Verify and securing every access request regardless of the location. Wow. 8 people got this, 1 person got it wrong. Awesome job, guys. Awesome. Let's see who is topping the board. I don't know if Sams is going to maintain this his position because I'm thinking one-on-one. Olix can decide to overthrow Sams, but let's see anyway. Wow, Sams is still topping the board. Awesome, but there is something I noticed, right? Allen Key overthrew Choose. So Sams, well done, well done. You are keeping this up, but Sams, you have to be very careful because Olix is like just 1 point very close to you, I'm sure Olix is planning an overtaking. Let's see what happens in the next one. All right, quiz question 4. Right, what are the zero trust guiding principles? What are the zero trust guiding principles? Who is going to win this one? Who is going to win this one? Who is going to win this one? Let's go. Who is going to win this one? Psalms, will you be on the board? Psalms, will you be on the board? Olix, will you top Psalms? Ames, will you beat Olix? Who is gonna win this one? Who is gonna Jay? Jay, I've not been seeing you on the board, though. You need to do better. If you want to beat Psalms, you want to beat Olix, you want to beat Ames, you need to do better. Olix, this one you're already crying beforehand. It's like you did not beat Psalms, so Olix, what's going on? You know, you don't used to fall my hand before. What's going on, Olix? All right, let's see who wins this one. Wow, we have 6 people got the answer correctly. Avoid a binary choice, both identity and network centric controls. Looks like this was a bit of a tough one, but let's see who is going to top the board. Wow, Sams, you are still rocking this. Ah, Olix, you allowed Allen Key to beat you. Hey, eh? Ames, you are still sitting on the third position, Gidigba. And then I see Tunde Ayeni. Tunde Ayeni beat that guy and became the 4th person. Interesting. Olix, see how you fall our hand. Eh? Olix, what's going on? Alenki, well done, Jerry. Well done, well done. I see what you are doing. Well done. All right, let's go to the next question and let's see who wins this one. Question 5. What does Amazon VPC Lattice help with? Who is gonna win this one? Let's go. Who is gonna win this one? Who is gonna win this one? Are they going to beat Sams? Because this guy no one agree. This Sams guy no one agree. Who is this Sams guy that doesn't want to agree? He doesn't want to agree to be. Who is this Psalms guy? Let us know now. Who is gonna win this one? Who is gonna win this one? Everybody has answered though. All right, let's check. Let's check. Let's see who is winning this one. Hazan, I see you. 7 people got this correctly. Make it easy to connect, to manage, connect, and monitor and secure communications. Awesome job, guys. But let me see if anyone will beat Sams. This one that they beat Olix, but Ames still stand Gidigba. Wow, Sams. Ah, this Sams guy in a spirit. Oh. Sams, you be spirit. Talk true, talk true, talk true. How are you maintaining the position all through? But well, kudos to Allen Key. I see Olix is back. And Ames, oh, sorry, Ames. Oh, I see Ames has gone back to the 4th position. But Olix has decided to come back and fight for his position with Allen Key. So let's see if Olix will be able to stand his ground, because forget it, Samson or Sams is not giving them space at all. Sams is not giving them space. Anyway, this will be the last question to decide who wins this. All right, guys, on to the last question. Who is going to win this one? What is the role of an AWS security group within a VPC? I mean, this should be quite easy, but I mean, let's see if Sam will maintain the top position, or maybe that guy called Allen Key is going to decide to say, okay, it's time to deal with Sams and take the first position. Wow, everyone has answered. But guys, before I reveal the answer, I have seen this happen times and times again. Sams, don't be too comfortable before I reveal this answer. You know why? I have seen a situation where in the last minute like this, somebody that will just come from nowhere will just carry the first. But I'm open-minded. Let it not be that I'm taking sides. I'm open-minded, right? So I'm gonna be showing who this winner is. Let's see who this winner is. Awesome, awesome, awesome. All right, we are revealing the winner now. Wow, everybody got this correctly. Awesome. To control inbound and outbound traffic to instances. Wow. Who is excited about revealing who the winner will be? Olix, calm down, Olix. I see you are giving thumbs up. Kwan, relax, 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 relax. Who do we think the winner is going to be? Who is sure? Who is very sure who this winner will be? But my mind they tell me say Sam's feet still maintain his position, child. All right, it's time to reveal the winner of this quiz session. Panadam, panam, pam, pam. Hey, sounds my guy. Wow, Sam stood still, he stood his ground, and he won the session. Congratulations, Sam. Congratulations. But also, I want to give kudos to Allen Key, right? And Olix. Allen Key came from nowhere and he just did one kind of somersaulting and then he took over Olix's position. But well, since Olix said, well, maybe let me give it to Allen Key, he decided to take Ames' position and he's the third. But for this particular quiz session, we are going to be rewarding just the winner, guys. Just the winner, guys. Sorry about that. So, the winner, please send us an email, right, to link send us your LinkedIn profile, your email address, your phone number, your Twitter handle, and a very nice picture of yourself. Yes, Psalms, please send us a very nice picture of yourself. So, looks like at this point in time, I'm going to be calling on Mimi. Mimi, are you ready for us now? All right, I see that Mimi is back. Hello, Mimi, how you doing?
Hello, everyone. Sorry about the
Yes,
network.
Mimi,
Working well throughout, and suddenly it just went. But
I
I'm back,
understand. I
and that's
understand. I understand. All right, I'm going to be handing over this to you. Please go on, Mimi.
okay. All right. So I'm sure we really enjoyed the session. I personally was very much invested in the quiz, and I didn't want it to end. So kudos to everyone who participated, and congratulations to the winner. Now, ladies and gentlemen, our next speaker, no other. Now, I understand we've had a lot of amazing speakers on this platform. Our speaker currently has 10 certifications. Now, this was one thing that really caught my attention because I can remember when I got my first certification. Oh, it was not easy. It was really, really difficult. And to have a whole 10 certifications, one to the two, to the three, to the four, to the five, up until across very, very skilled aspects of tech and cloud. Ladies and gentlemen, our speaker next up is a product manager, and he is also a solutions architect. With great happiness and joy, I welcome Mr. Samson Sultan. Please give a round of applause from your houses. Welcome, Samson. We're happy to have you here, and we're happy to listen to you as you pass in us today.
Thank you, Mimi. Thanks for the opportunity once again. I'm also thanking everybody listening for joining this session. I hope that we've been enjoying the session so far. I can attest that for that my previous speaker, it was like we peeped through our notes before coming up for this session. Now, I could say that he shared a lot about what I'm about to share, and I'm also going to pinpoint about what he also shared. Again, thanks everybody. Without further ado, I'll just start this session. Mimiki, please can you help with the slide? All right, all right. So for me, I'll be talking about how you're going to secure your AWS resources and services using physical components while in compliance with well-architected framework and zero trust model. Previously, we had a very detailed class, a very detailed session about zero trust model. I will also be sharing a bit about zero trust model in this session. So I want to talk about how we're going to be using each of these models or each of these zero trust model and AWS Related Framework to address security control planes within AWS Cloud Services. My agenda for today is basically introduction, which Mimi has taken. Thanks Mimi once again. What is zero trust model? What is the AWS Well Architected Framework? And focus on the security pillar. Then which of these DPC components speaks to security of AWS services and resources? And finally, we'll be looking at AWS Security Hub. Next slide, please. All right. So I have this statement, which while I was coming on my slide, I realized that I need to look for a teaser where can trigger our taste. And I would start by saying that security is not just a practice. You agree with me that today security is an attitude, which means that it's not just a technology, it's not just a process, it's not about being a policy anymore. It has to be an attitude that everybody within the organization has to portray. Of course, it requires continuous detection and continuous improvement. I'll flip it on the other side to say, the regular CI/CD, which is continuous integration and continuous delivery. In this case, security means that apart from the processes, apart from the technology that that's been deployed within the infrastructure, be it a hybrid or be it cloud, you also need to portray the attitude of security across the landscape of the organization, starting from the product owner, starting from the business owner, the CEO, the CFO, the CIO, the CTO, the IT team, and even the business team. So even if IT has put in security measures in place and a regular user of the infrastructure, a regular user of the application seems to be the vulnerable user, it can cause a lot of issues. It can cause a lot of threats within that infrastructure, despite the fact that there have been processes, actions, and technologies put in place. And that's why we say that security must run in every organization's DNA. It means that every organization must see security as a DNA attitude. Next slide, please. All right, I won't do too much here because our previous speaker already mentioned about zero trust. I will only deviate a bit from the angle where you mentioned about zero trust. Again, zero trust is just it's a framework. It's not a product. It's not a service. It's basically a strategy. It's basically a framework that helps organizations to actually shift away from a traditional security perspective. Traditionally, we are used to network security, which our previous speaker already mentioned. Network security in the sense that you want to secure the north-south security control plane, the east-west security plane. However, it doesn't put up the entire security posture. It doesn't increase the security posture on the holistic view, which means that if today you are just using a WAF, which is the web application firewall, you're just relying on your regular firewall, the likes of Palo Alto, the likes of Fortinet, the likes of Sophos, or even relying on only AWS firewall, and you are not looking at other planes or other levels of your infrastructure, it means that at the identity level, you might be vulnerable. You might be fine on this network perspective. There might not be bilateral movement of virus or issues or threats within your network infrastructure. But what happens on the data plane? What happens on the application plane? What happens on the identity plane? What happens on the endpoint plane? So all of this put together makes you to conform to zero trust. And so they're saying that at every layers of the the OSI model, you need to trust. It means that at every point in time, do not trust anybody. Say for instance, I will use a case in point. You own a house, and because you have given access to a previous visitor to your house, it doesn't mean that when the visitor is coming next tomorrow or when it's coming the next time, it should be given free access. It means that tomorrow the visitor might be vulnerable, maybe due to one reason or the other. So it means that at the next time of visits, you need to also check that visitor to ensure that the visitor comply to all your rules within your security posture. But for you to come into the house. So that applies to zero trust. That's what zero trust is saying. That at every point in time, you need to ensure that you trust each data, each applications, each users at every level of entry point or even exit point. Next slide, please. All right. So I mentioned earlier, I said security is a strategy, it's not a product or service, which means that do not expect that security should be a product or security should be a service. It is something that you need to implement. It has to follow best practice. It has to follow the National Institute standard, which is NIST. So I'm saying this because the previous speaker did not mention the area where what brought about zero trust. So looking at this particular diagram, I'm going to tell you the layers of zero trust. Basically, we are saying that from the identity perspective, identity can be human, identity can be users, identity can be applications. So that's why you have human and not human. So from the identity perspective, you need to ensure that you have strong authentication, strong authorization. So some cases you might need to enforce multi-factor authentication. What I mean by that is not just using username and password, especially for admin users. You can enforce some level of conditional access policies where you can ensure that they verify the location they are accessing the resources from. They verify the IP address they are accessing the resources from. They also verify their identity in terms of truly are they who they are, do they have access to XYZ. Even you can even go further to say they have access to specific applications, specific resources within infrastructure. So that's on the identity side of things. And at every point in time, when the IP or the location of the users change, you can enforce them to trust the identity again. The second part is endpoint. Now with the advent of BYOD, which is bring your own device, with the advent of work from home, a lot of people are used to using their mobile devices, their personal laptops for corporate work, for organization work, organization tasks. How do you ensure compliance? How do you ensure governance? When it comes to people using their mobile devices, their personal devices, for their daily activity of the organization? You need to have solutions in place that help you to cover this device management. That's for the endpoint perspective. You can see for corporate devices and personal devices. Then I move to the around of data. We have data scattered around different areas, different locations of the infrastructure. A case in point with AWS, you have the data that can be sitting on an EC2 instance, you have the data that can be sitting on an S3 bucket, you have data that can be sitting on your RDS, you have data that can be sitting on serverless functions, you have data that can be sitting on EKS, ECS, you have data that can even be sitting on IoT cores, so IoT devices. How do you aggregate all of this data to ensure that at no point in time these data are not vulnerable, these data are not compromised? Zero trust is also saying that at that level of data security, you need to ensure that you do not trust whoever is accessing those data, and they need to be trusted at every point they are accessing the data. Applications. Previous speaker already mentioned that with AWS IAM role. IAM role gives you the availability or the flexibility whereby you can assume a role for you to be able to interact and communicate with other applications or other services within AWS. So I have an EC2 instance and that wants to communicate with either KMS or it wants to communicate with X3. Instead of making the application or putting the application or encoding username and password or secret into the application, so that you can access my X3 bucket or access my DynamoDB or access my KMS. with the IAM role, the application can assume that role and access this server services. That's the purpose of apps, and not just applications on AWS cloud. A good thing that you can even leverage hybrid services, which means that for your on-premise application, they can also assume this IAM role. So far, they have a kind of connectivity with AWS. Infrastructure, like I said, infrastructure is basically everything that has to do with compute. You have serverless, you have the EC2 instance, you have the EKS, you have the ECS, you have your PaaS. All of these services that falls within the infrastructure. You have the lambda function, you have the step function. All of it as well. How do you ensure that at the time you are running your code, at the time you are processing data, at the time you are processing your runtime, data or secrets are not vulnerable, or they're not being compromised? With zero trust, it gives you that flexibility. Finally, on the network level, again, we already know that with our firewall, you can have some level of security. But however, you are still exposed if you don't build your network level up to the zero trust model. And that's why you have several segmentation possibility, traffic filtering, firewall, rules filtering, in and out, tracking policies across board. You can see all of this plugs to the zero trust policy, and on the north side and the south part of the zero trust policy, you can see policy optimization, you can see trend protection, and that gives you, compliance level and governance level, and ensuring that you increase your security posture. Basically, security posture just telling you about how vulnerable are you, what is the percentage rate in terms of how secure the environment is, basically. Next slide, please. All right, so we have some standard principle for zero trust. These are key things. They are global standard for zero trust principle. I'm just going to try and skip things that my previous speaker already mentioned. The first thing about zero trust principle is verify explicitly. When I say explicitly verification, it means that do not trust at any point in time. At every point in time, you need to authenticate and authorize. Is it from the data point? Is it from the user identity? Is it from the device else? Sometimes my device might be healthy today because I have a compliance level at 100%. But tomorrow, say for instance, I mistakenly uninstall an antivirus on my mobile device. It makes that device non-compliant. And if at the next point of authenticating that device, or at the next point of using that device to access corporate services or corporate data without zero trust principle, it means that I'm already infiltrating issues into the organization because that device is more compliant. But because of this verified explicitly, it means that at every point in time, verify, even down to data classification. You want to know if this data is personal PI data, which is personal information, identified information, which is compliance with GDPR. You want to ensure that you classify your data to be personal data or corporate data, or data that should not be exposed to the general public. You can have granular level of classification or explicit denial of what data people can access to. On the workload level, you can even provision or segment workloads across board. Use least privilege access. I'm sure this is not a new word to everybody. In AWS, it is a key. It is key for everybody. It's key for every architect. It's key for every cloud architect, solution architect, or cloud engineer, to ensure that you do not give excess permissions to users, excess permissions to identities, excess permissions to applications. The reason is not far-fetched. If, for instance, I'm a developer and I only manage 3 applications, I do not need to have access to other services hosting other applications. I do not need to have access to, if I'm just going to commit my deployment to just 3 applications. Why do I need to have access to the KMS? Why do I need to have access to EC2? Why do I need to have access to S3? Really, I do not need to. So that's the reason of using least privilege access. It's purely to say that only grants granular access and permissions to whoever that needs it at the point it is required. And that's where you also have just-in-time access. It means that you can build granular access as at when people need it. it doesn't mean that at every point in time you can even review the access of user, review the access of identities like woman, like applications, like EC2 instances based on what they have accessed before. Then assume breach means that do not believe that you have an 100% secure environment. Be ready for any security threat that might come in. So at every point in time, ensure that you have a login, a login tool in place. You have a SIM in place. You have a SOA in place, such a way that you have a visibility of what is happening within your infrastructure, within your environment. Again, a lot of people feel like once they have implemented the security best practice, or if you have implemented zero trust, you can go to bed and sleep. You cannot go to bed and sleep, because as much as we have good actors, we have bad actors that are, on a timely basis. If it's not on a per minute basis, people are sending you those attacks to your web servers on a per hour basis, just to bring down your services. So for that reason, you have to continuously improve on your security posture. You have to continuously improve on your security control planes. Next slide, please. All right, so now that we've talked about zero trust, we've heard about a lot about zero trust today, and I can tell you for sure that if they should wake anybody up tomorrow and say, okay, tell me about what do you understand about zero trust, you won't say, oh, zero trust is a technology, or zero trust is an action plan, or zero trust is a product. No, we already know what zero trust means, the principle guiding zero trust, what you need to put in place around zero trust. So now that we have AWS well-acted framework pillars, I can tell you for sure AWS, just like the previous speaker said, AWS are huge on security. When I say they are huge on security, they breathe, live, eat security. It's one of the cloud providers that I can totally say that 100% security give it to AWS. And the reason is not far-fetched. It's because they are constantly evolving, which means that at every point in time, sorry about that, please. Hello, can you see me, please, Mimi? Hello, Mimi, can you hear me? Please let me know if okay. All right, thanks, promise. All right, so as I was saying, which means that at every point in time, AWS are constantly improving on their security level, on their control planes, and that was why they brought up the AWS well-acted framework. It means that what it means basically is saying that after moving your services to cloud, or you are either you're innovating or you're migrating to the cloud from an on-premise infrastructure, or you're building an hybrid infrastructure, you also need to continuously verify, access, audit your workloads are in the cloud already. And that's the purpose of well-acted framework pillars. They are built on 6 pillars basically, and one of them is security. I'm just going to touch base now, summary on the 6 pillars, whereby I will focus on, excuse me please, whereby I'll focus on the security pillar. I'm going to start with operational excellence. Basically, it's just saying that how once you have moved to AWS cloud, how do you ensure that your operational or your efficiency in terms of your operations? How do you ensure that processes are being followed? How do you ensure that you are deploying, you are using your DevOps tool? How do you ensure that you are using the best practice in terms of support, in terms of process development, commit, in terms of deployment? How do you ensure that people can continuously support that infrastructure? That's operational efficiency. Operational excellence. And then we have reliability. Now, we all know that today, we sometimes you need to build your infrastructures to be able to accommodate disaster recovery, so that you also be able to accommodate high availability. Today, how do you ensure that if a particular region of your AWS go down, where you have your services running, which is very rare, can you quickly scale? Can you quickly bring your services up if there is a downtime? So how do you ensure that your services are up and running at any point in time, even peradventure there's a downtime, even peradventure there is a security breach? That's the reliability function of the reliability pillar of the AWS related framework. Then performance performance efficiency. Basically, that performance efficiency is just telling you that on your AWS, how can this quickly scale? Sometimes some people will build infrastructure without putting elasticity in place, without considering scalability. If, for instance, you build your mobile application, or you build a web application basically for shopping, and during peak period, say for instance, Black Friday is coming up, and there is a huge peak of your shoppers on your web, on your shopping web. How do you ensure that your services can accommodate that huge peak period? That is where performance comes in. A lot of people, or some people today, do not know putting all of these things in place. AWS is saying that at every point in time where you are optimizing, where you are ensuring that you audit and assess your infrastructure, or you assess your workload, you need to ensure that you build in scalability, you build in performance. Today you might have an EC2 that the compute resource is a bit low. Tomorrow there might be a peak. How do you ensure that it can quickly scale using the auto scaling group function services? That's around performance efficiency. Cost optimization. I can tell you for sure, one of the reasons why some people are not moving to the cloud is because of cost. And it's because they are not well informed about the cost involved, or the cost that they will incur after moving to the cloud. A lot of people today are saying that, oh, I will remain in my on-prem because I have an understanding of how much I've spent building this data center, putting this infrastructure in place. However, no, you cannot really manage your on-premise infrastructure. You cannot, again, scale that on-premise infrastructure if the need arise. You might need to quickly buy servers. You might need to quickly get some other physical hardware if you want to scale, which increase your capex. Again, there is lifespan when it comes to having your own data center. But with cost optimization approach pillar for AWS cloud, it is already an OPEX model, which means that you only pay for what you use. Again, with the help of Trust Advisor, which is an AWS service, you can quickly tell which of the services are consuming more cost or more on your infrastructure. You can tell which of the services are not even being used, and whereas you're spending so much on them, which all of this can help you build your cost matrix, and it can help you make an informed decision to your CFO to say, okay, sorry, we need to bring down this cost. We need to re-architect our infrastructure so that we can reduce cost. The next is sustainability. Now that we are building, everybody are talking about green environment, secure environment. So it means that the carbon monoxide that we are burning on a daily basis affect our ozone layer, and of course affects the entire weather nature. And that's why we see that people are moving from power generation, regular power generation, to solar generation. Again, AWS has put that in place. Sustainability helps you to measure how you can minimize the impact of overutilizing resource workloads that can affect the green nature. That's basically what sustainability is doing for you. Finally, on security, security is basically saying that at every position, you need to be able to ensure that you secure your data at every level. Next slide, please. All right, so like I said, our focus point is on the security pillar. Now, there's a statement that said security pillar focuses on protecting your information and systems. We've mentioned this over and over in the course of this meeting, that you cannot take away security. Security is no more a process, no more a plan. It is now an attitude that has to be a constantly evolving within an organization. Now, it describes how you take advantage of cloud technologies to protect your data across board, not just your data alone. Of course, we have mentioned about zero trust, which means that on the layers of zero trust, from the application perspective, down to the endpoint perspective, down to network perspective, data perspective, you need to secure all of that. Now, for AWS and even for other public cloud, there are common security design principles in the cloud, which are basically 7 in each. There are 7 principles, which is unique and standard. It's across board. Number 1 is use least privilege policy. We have talked about that a lot of times earlier. Number 2 is enable traceability. At every point in time, this is where monitoring and logging comes in. People need to have visibility on what is happening within their AWS cloud. Today, how do you ensure that you are using CloudTrail to monitor your account, what is happening on your account, your AWS account, who is creating what? Because all of this is actually an API call. Who is creating what service, at what point is a particular service being created, who is deleting what, and all of those. How have visibility on every action that is happening within your AWS account. Traceability, cloud watch logs. You can see, you can expunge or ingest data into cloud watch logs from different log sources, so that you can have visibility across and analyze further even on X3 buckets. That's where your traceability comes in. Security at all layers. We have mentioned that over and over. I won't get too much of that. At every layer of infrastructure, ensure that you have security. Conform to zero trust. Automate security. Today, do you have an automation tool? Automation is key. You have seen DevOps practices. You've seen CI/CD tools. You have CloudFormation from AWS. You have Terraform that can help you to automate a lot of services, a lot of approaches in deploying your infrastructure. So again, it applies to security. So do you have a SIEM solution in place? Do you have the likes of AWS Inspector in place? Do you have the likes of AWS Guard Duty in place that can help you to have visibility and quickly automate or remediate whenever there is an issue or whenever there is a sense of vulnerability within your cloud infrastructure? Protect data in transit and at rest. Earlier we mentioned that when we are trying to access AWS cloud, from the customer perspective, the tunnel is a TLS tunnel, and it is encrypted and also signed with ZIG4 encryption, which means that when you have data in transit within the customer perspective to AWS cloud, even within AWS services, how do you ensure that all these data are encrypted? How do you ensure that people are not sniffing through the tunnel to steal or to sniff over critical data or the confidential data that is moving around services deployed on AWS? When data are at rest, you have data that is sitting on S3 bucket, you have data that is sitting on DynamoDB or RDS. And how do you ensure that at every point in time this data can be secured? That's where the likes of custom managed keys comes in. The likes of AWS managed keys comes in as well too, so you can encrypt your data with keys at every point in time. You can even import your keys into AWS such a way that you can manage or secure data at rest. And you also have cloud HSM. So that's ADO security module, whereby you have a security module that is of higher ruggedity to help secure your data at rest. Prepare for security events. I can tell you for sure, like I mentioned, as Zoom Bridge, do not believe that you have an 100% secure environment. So at every point in time, ensure that you have SIEM visibility or SIEM solutions or SOAR solutions to give you alert on security events or logs coming from, it could be Linux, it could be from application, it could be from application inside and the likes. Then minimize attack surface. Again, try to avoid manual errors. That is the correlation with automation. When people decide to manually create things, when people decide to manually remediate things, they are prone to human errors. So on this level, which is the 7th one, try to minimize human intervention. Well, that's why we have minimized attack surface. Next slide. All right, security best practice. Security pillar best practice. When we look at the AWS security pillar best practice, it's only talking about what's the responsibility as a customer, what's my responsibility, what's the responsibility as AWS. For today, AWS take a part of the responsibility. You can see, previously what my co-speaker mentioned about. From AWS perspective, they've been able to put in some level of huge security posture in place or security plate in place. An example is the IAM role. IAM role is it comes by default with the AWS services. Another example is the KMS, which comes by default with AWS. However, it doesn't it doesn't still say that as a customer you don't need to secure your data, you don't need to secure your environment that's in the cloud. AWS take charge of the security of the cloud, which is the underlying infrastructure, the hardware, that cloud infrastructure is built on, the virtualization layer that the infrastructure the cloud is built on. But when it comes to the customer, it changes as we move from different cloud types, be it from the IaaS perspective, from the PaaS perspective, on the SaaS perspective. From the IaaS perspective, you have a lot of responsibility from the customer side to build your security posture. Basically, you're subtracting, for instance, you're trying to AWS EC2 instance. You need to ensure that you patch the EC2 instance. You need to ensure that you update the EC2 OS. You need to ensure that the applications that are built on that EC2 instances are being updated, are being secure at every time. You need to ensure that identity that have access to in and out of that EC2 instance are being guided. So that's a lot of responsibility as the customer from the security perspective when it comes to your responsibility. Again, on security pillar best practice, we have key standard from AWS. The first point is basically talking about account management. Today, a lot of people that want to move to AWS, we started from a testing phase. Unlike the financial services, the FSI, unlike other the telcos or oil and gas, they already have big infrastructure and they want to do some form of lift and shift to the cloud, which means over time they can now modernize the application or they innovate the application. But because they want to move to cloud, they do a lift and shift. In that case, you need to plan how you want to have your account. You need to segment your account. You might need to have separate accounts for dev, which is development, or test. Separate account for production. You might also need to you might want to categorize them based on business types. You want to have it for, say, for instance, for finance department. You want to have it for project teams. You want to have it for security teams. You can build your account in that manner and separate and segment them. And that's where you have the AWS organizations where you can use to manage multiple AWS accounts, and of course organization units within the software of that organization. So it is best practice when you are planning security, because you might have governance and compliance policies that you want to apply to some business units that you don't want to apply to other business units. Take for instance production. You need to ensure that your production environment is well tightened and conform to different areas. If you're in the FSI industry, say for instance PCI DSS ISO 27001, will have to be complied to your production environment to comply to all of these standards. However, if it's a dev environment or a text environment, which is being used by internal developers, you might say that, I don't want to enforce entire policies on that. So you need to be able to segment all of this into different OUs and manage them within the AWS organizations. And that's again where the SCP comes in, security control policies, where you can apply it from the top hierarchy down to the least hierarchy within the AWS organizations. The next thing is a workload operation with governance approach. A lot of times, governance is not a technology; it's a strategy. It's also a process that ensures that organizations are conforms to standards. An example of standard could be PCI DSS, like I mentioned, could be HIPAA, it could be GDPR. So depending on the organization that you have or that you run, you will have different governance policies or different governance approach that you need to apply. And people need to be able to operate their workload in compliance with governance. Because without governance, it means that you run your business as usual. The next is IAM. We all have heard from the previous speaker, identity and access management. How do you ensure that at every point in time, again, this is also related to apply the least privilege policy. This is about IAM as well to ensure that you only give necessary identity to who you need to have access to. You do not grant root access to everybody. Your root account should not even be used at any point in time. Your root account should not even have secrets attached to it. These are best practices that you need to follow when you are building your security pillar within the AWS cloud. The next is detection and monitoring. I've talked about having a visibility into your workload. Today, it's not just about building a very good infrastructure, modernizing your application or modernizing your workload on AWS cloud. there can be issues at any point in time. It's not even security issues. It's not even security threats. How do you know if you have different microservices now building up a particular application? You have services running on SNS, services running using SQL, services running AWS Lambda or step function, and communicating with X3, communicating with EKS, communicating with EC2, and holistic building your applications. All of this tied together. If you don't have a visibility at every point of what API calls is going on, at what point is the let me a case in point. You have the mobile banking app, and some users on the Android platform are complaining of user experience, on the mobile app. Why users using the iOS platform are not complaining? If you don't have visibility in terms of detection and monitoring, you will not be able to trace where these issues are coming from. Is it on the application level? Is it on the connectivity level? Is it on the data level? Is it on the database level? Is it on the API level? So with all of this put in place, when you have detection and monitoring, you can build that visibility. Next is infrastructure protection. We mentioned about earlier, network and compute protection. It is not far-fetched. In the course of this session, I'm going to talk about how we can protect our compute, how we can protect resources with the VPC components. Skills in place. Earlier, the previous speaker talked about security groups, talk about private links, talk about NACLs, talk about VPC lattice. These are tools or services that build off the shelf on AWS that can use to protect your infrastructure. The next is data protection, basically classification. I tell you earlier, you should be able to classify your data in terms of, is this company-wide, is this corporate data, is it personal data, is it data that has PII, is it data that are confidential data, is it data that requires highest level of integrity. That's another security that we need to put in place. I've already mentioned about protecting data at rest and in transit. Next is incident response. Again, a lot of people have beautiful log analytics in place, cloud watch logs. They have trust advisor, they have CloudTrail in place. They even have Amazon Guard Duty, they have inspector in place. But how do you quickly respond to incidents where you see alerts, where you see your issues coming from all of these services that you are using as visibility? That's where the incident response comes in. Do you have a SOAR in place? Then the lastly is application security. A lot of times developers are only concerned about, oh, I want to ensure that I build a good UI UX application. I want to ensure that my application is agile. I want to ensure that my application is scalable. I want to ensure that people can access my application wherever they are. I want to ensure that my application has content delivery in network service in place so that it can users can catch that whatever data that are frequently accessed. While leaving the security part away from this development or architecture, it is key to putting security into application development. Again, we are not saying that AWS is not saying that you should encode password into. Okay, AWS is not saying that you should encode password or secret keys into your applications. Those are the back in the days where developers have to have a like a sheet where you can have all your secret keys. That's traditional way of securing your applications. Now we have different ways that you can secure applications. Next slide, please. All right. This is also one key point that I'll just I'll talk briefly on in terms of security lifecycle. Basically, when it comes to security in the cloud, security on-prem, security in an hybrid infrastructure, it's all about ensuring you have a high security posture. I'll talk about what security posture meant earlier. And it's a cycle, which means that it's a continuous activity, it's a continuous process. The first thing is identify. How do you ensure that you are identifying your assets? Now you need to be able to identify assets, data across the layers of zero trust I have mentioned. Your device, your endpoint, your application, your network, your identity. How have you been able to know? You need to be able to identify critical data points, critical assets that need to be secured. As much as you want to secure everything, but you also need to identify critical data points that need to be secured. Again, once after you have identified, you need to now protect. Now, protection comes into protecting the control planes and protecting the data planes. Like my previous speaker mentioned, in this case, you're not just doing a network centric protection, you're also doing an identity centric protection, not having one over the other or having to choose one and leaving one aside. It has to go hand in hand, which means that your network centric protection and your identity centric protection comes intertwined for you to be able to build a protection level or a security protection level within your cloud infrastructure. Detect. After you are protected, you've protected your infrastructure, you have to continuously detect, which means that you have to have tools in place, services in place that can help to continuously detect what is happening. That's where you have, like I mentioned, the likes of Inspector, the likes of Massey, the likes of Amazon Guard Duty, where you can help to detect vulnerabilities and the likes. Respond. Once you have detected any vulnerability or any threat, you can quickly respond. You respond with other services. You can even respond. You can have some form of lambda function to say that once a particular, you can create an automation to say that once a particular vulnerability is being detected, or once you realize that a particular identity is being breached, quickly disable that user, quickly trigger a mission to the administrator, quickly disable access to that particular identity across other services. You can configure automations in terms of response that way. Then recover is like your remediation. You need to have remediation plans in place, which can also be action plans that has to do with having security tools in place. Next slide. All right. So on our agenda, I already mentioned this is like the third line on the agenda, which I'm going to deviate a bit from what the previous speaker mentioned around the tools or services available on AWS. We have numerous services. Like I said earlier, AWS is huge when it comes to security in the cloud, and when it comes to security of the cloud, it is huge. They have more than 300 plus services that you can pick from that you can use to secure your infrastructure. We've heard about lattice, we've heard about security groups, we've heard about verified permissions, we've heard about other services like I am. Here I will just be speaking about the VPC components that speaks around security. Again, this is not one size fits all. It means that you'll be looking at other, if you come across other services like KMS, like secret manager, there are a lot of other services that are not mentioned today that can address security of of the resources and services in the cloud. But looking at this, I'll be focusing more on this diagram. What's a VPC? We all know what a VPC is, but for the benefit of those that join late or for those that are new to AWS cloud, basically a VPC is an overlay network. A VPC is a virtual data center. So traditionally, organization will build their data center. Some for small organization they call it server room, where you have to put up rack and stack up servers, stack up storage, stack up network devices, switches, routers, firewalls in place just to ensure that you use it to build your business operations. Basically, that depends on IT. Now that we are moving to digital transformation, companies are moving to the cloud. And VPC is saying that instead of having to build your own data center, or instead of having to build or co-locate in a private data center, you can build your own data center in the cloud. That's what VPC is. It's basically a logical data center. So everything that you can think of that's in a physical data center are available on the VPC. It's your own dedicated virtual network. So it's an overlay network. The overlay network is saying that it's built on top of it's a logical virtual network built on top on a physical network. So again, I will go back to what we call software defined network. It means that there is an underlying physical device actually on AWS cloud, which means that there is actually stack up rack, which has servers, which has a lot of multi-connected storage, multi-connected switches, multi-connected routers, and all of these are built with software-defined technologies. So with the software-defined technologies, we can now have logical data center for each customers. So again, people will say, "Oh, what happens? Does that mean that my data is shared with another customer?" No, that's why it's called a virtual private network. That's why it's called an isolated virtual data center. It is just isolated to you. Today, even if you create another VPC tomorrow, if you not in a way pair those VPCs together, VPC A cannot communicate with VPC B. That is that granular, is that secure. So even as the owner of the two VPCs, if you do not in a way pair them together, it means that you cannot communicate or have access to VPC B if you are not given the privilege and permission to access VPC B. That's it. Looking at these VPC components, I will start from as much as small as what a security group is. I won't have to define that, but I will just tell you how best you can use security groups. Our previous speaker has told us a lot about it. The security groups actually applies on your interface layer, on your NIC layer of your EC2 instance. So it means that you have your private subnet, you have a public subnet. Again, just to digress a bit, for the benefit of people that are not aware of what public and private subnet is. It's just like when you have you have segment your data center into VLANs. So today in a traditional environment, I will create a VLAN to be able to segment my network. Say VLAN A is called for finance, VLAN B is for technology. It's just way to ensure that there's some form of stabilization, just that they cannot communicate with each other. That's the purpose of the VLAN. That bring that ideology into private, into creating a subnet. In each VPC, you can create as much as 200 subnets within each VPC. And again, within a region, by default, you can create a maximum of 5 VPC. So it means that if within a particular region of AWS, say for instance the island region now, I can create a maximum of 5 VPCs. And within that VPC, I can create a maximum 1 VPC. I can create up to 200 subnet. Now, what's the concept of having private and public subnet? It's not far-fetched. Within a traditional environment, you will have I want to take us back to the firewall concept. You have something called DMZ, which is demilitarized zone. That's when you are using the concept of traditional infrastructure where you have a data center, and you have other zones, your LAN zones. Your LAN zone is basically your internal infrastructures. They are all fully private IP address. And while your DMZ is actually your internet facing applications where you have your web app, where you have your web application deployed. That's on the level for traditional data centers. Now bring it back to AWS cloud. Your private subnet is basically saying that every resource that you deploy within your private subnet only have what we call a private IP address. You can have multiple interfaces on the EC2, of course, but you can deploy other services within your private subnet. But your public subnet means that these are subnets that will have internet facing. They want they can reach internet, and with the help of the internet gateway. That's what makes a public subnet different from a private subnet. It's just the internet gateway. The internet gateway is of course attached to the public subnet, unlike the private subnet. That being said, it means that by default, if I need to communicate from my private subnet outside to the internet, you cannot. You might need to bring in some level of NAT gateway, which is also from an appliance, a virtual appliance that helps people or EC2 or the services within the private subnet to be able to access internet, not backward. So it's not a bi-directional communication when it comes to NAT gateway. So example is you have servers that need to download patches or that need to download updates from the internet, but you don't need them to be able to. You don't want people to access those servers or those EC2 instances from the internet. That's where we're going to use NAT gateway. That's the form of security. Those servers can have access to the internet by downloading patches, access to some specific website, but users or people cannot access those EC2 instances. Again, security groups. Now back to security groups. Security groups is just like firewall rules. Think of firewall again, where you can only create allow rules. In AWS, there's also called network access control list, which is applied on the subnet level. Security groups is applied on your interface level, your EC2 interface level. So when you are coming into the VPC, if the traffic is coming into VPC, if you look at this diagram, take it from the internet, coming to the VPC. At first, the NACL, which is the network access control list, comes into play. It looks at the allow and the deny rule, because NACL is stateless. It also has it supports both allow and deny rule, unlike the security group, which is a stateful firewall. And of course, it only permits the allow rule. There's no denying when it comes to what's it called, security groups. It has an explicit deny already. So you need to create an allow rule for it to be able to either for in-out traffic or inbound traffic, inbound or outbound traffic to come into your EC2 instance. That's on the level of how much you can use all of this, these two virtual firewalls, let me call it that way, to secure resources within your AWS cloud. Next thing I'll go about is I talked about NAT already. The next thing I'll talk about is the VPC endpoint. I will not dwell too much around that because the previous speaker already mentioned about VPC endpoint. Again, you have some public AWS public service like DynamoDB, CloudWatch, KMS, X3 buckets, and you want services in your private subnet, services within your VPC to have access to all these public AWS public services, not over the internet. No, you want them to go through the AWS backbone network. However, you want them to communicate as if they are speaking to a private network. That's where you have the private link. So the private link is another service that comes by default with AWS VPC component that can help you to ensure the private connectivity between your services deployed on your private subnet and your AWS public services, like I mentioned, AWS X3, CloudWatch, DynamoDB, RDS. Another service that can help you within the VPS component is the AWS the Direct Connect. So today, you can see from this diagram, you have customers that are on-prem data center. I want to use the FSI, financial service industry, as a case in point. They are running hybrid infrastructure. They don't want to migrate all their workloads to cloud because they have some legacy systems that are still being used within the business that remains on-premise. However, they want to be able to establish some form of federation with those on-premise infrastructure, some form of identity management, those form of on-premise infrastructure, some form of API calls with those on-premise infrastructure with the AWS cloud. And they want to leverage site-to-site VPN. The easiest way to do that is just build a site-to-site VPN, which is saying that you create an encrypted tunnel over between the two layers, between your AWS cloud and your on-premise infrastructure, where you have like a customer gateway. A firewall can serve as a customer gateway, whereby you create an IPsec VPN between the two sites. However, it's still going through the internet. So internet latency can come to play, just like my previous my co-speaker mentioned that you might have issues when you're using VPN because it's not far-fetched. Internet, we are using internet at the moment, and we cannot guarantee all great internet. Latency comes into play, jitter comes into play, lattice comes into play when it comes to connectivity. But with direct connect, it's like you're building a private tunnel between AWS cloud and your on-premise infrastructure. You can use either the AWS backbone. You can use a partner connect, the likes of May1 that can help you to build that infrastructure. I'm speaking to for people that are connecting from Nigeria, that can help you to build that private link using direct connect. Lastly, on this page, I will talk about VPC peering. Again, you talk about VPC lattice, where you have multiple VPCs, and you want to be able to manage, monitor, and connect and securely connect all of these VPCs together. before the advent of VPC lattice, we have what we call the VPC, pairing and transit gateways, which means that I can pair multiple VPCs together and they are not transitive. So when I say not transitive, so if I have VPC A, B, and C, and I've paired VPC A and B together and VPC B and C together, it doesn't mean that VPC A can now communicate with VPC C because VPC B is paired with VPC C, and VPC B is paired with VPC A. It is not transitive, and that's where continuously AWS they are evolving, they are innovating new solutions, and that was one of the reasons that they brought up the VPC lattice, because they realized that users are complaining about even with transitive gateway. With transitive gateway is like you are creating an urban spoke technology whereby you have a transit gateway at the middle and you have your multiple VPCs, even your on-premise infrastructure acting as spoke to communicate with the transit gateway. However, you are limited with the capacity. You are limited with the capacity of the transit gateway. Next slide, please. All right, so I used all of that to actually explain this component for securing resources. The only thing I didn't mention here was basically route table and network firewall. So I'll just touch base now summary on that. So your route table, just so take again, routing is the connectivity is key. It's a foundation for every deployment that you have on AWS cloud today. It's the baseline for every communication that we have. So it means that there must be a pathway at which you are communicating from point A to point B. That's where your route table comes in. Your route table actually, it's a database that contains the next stop address, that contains the pathway to get to your destination from the source. So that's basically what the route table means. And with route table, you can create what we call UDR, user defined route, whereby you can say that instead of using the internet gateway to communicate to the internet, instead of using the NAT gateway to communicate, have access to the internet, instead of using some specific route, use my network firewall, AWS firewall, use this particular virtual appliance to reach this particular destination. And I'll now go to network firewall. Basically, your network firewall is saying that your security groups, your NACL are not enough to build an holistic or robust firewall solution within your infrastructure. Again, like I said, NACL is applied to the subnet level. Security groups is applied to the EC2 interface level. So in a case where you want to have a security guardrail at the entry port of your VPC, that connects to multiple VPCs and multiple subnets, what do you use? That's where the solution comes in for network firewall. Either network firewall or partner virtual appliance can be deployed in a separate VPC, and that VPC becomes like your guardrail to other VPCs or to other subnets within your infrastructure. So every traffic coming in and out of your VPCs and your subnet, gets to the network firewall first before and network firewall process based on policies that have been defined. Next slide, please. We will not be able to take it to the firewall manager because of time. All right, so this is the last topic on this session, which is the security up. I brought this up because I want people to be able to see the holistic view of having all of its AWS services for detection, monitoring, remediation, respond across different data layers. Now, your security hub is just like a central repository position or a central repository solution or service that's available on AWS. It's actually meant for you to improve on your security posture. It gives you visibility on a pane of glass. It makes that even with my AWS cloud and my on-premise infrastructure, I can see on a pane of glass what is happening in terms of security posture. How am I doing in terms of vulnerability? How am I responding to threats that are being infiltrated into my environment? How can I quickly remediate all of these things? And it's a combination of a lot of services into it. The AWS Security Hub actually has two major components. It has the SEND findings and also the receiving findings. Basically, it's saying that you can ingest data from the send findings. Send findings examples like AWS guard duty, AWS config. AWS config is basically a service that will access that evaluates your resource configuration. So how do you, on a continually basis, a lot of people have deployed resources. They have deployed your, even with your DevOps practice, with your Ansible, with your Chef, with your Terraform. But how do you ensure that the configurations are conform to compliance at every point in time? So with the AWS config, you can access, evaluate the configuration of your resources at every point in time, and you can also know triggers if there are compliance issues. That's AWS config. This is a service that's built into Security Hub. AWS guard duty. Basically, that is the threat detection solution or service that's available on AWS. A lot of times people will take it, how do I have visibility on when threat is coming? You have AWS mentality. AWS firewall manager. AWS firewall manager is actually a solution. It is a combined solution that has almost all the firewalls, all the firewalls in place. You have NACLs combined, security group combined, web application firewall combined, DNS rules combined into one. So your AWS firewall manager manages, instead of having to manage your security groups, NACL, one by one. With AWS Firewall Manager, you can manage all of this, holistically in one view. Again, system manager. The system manager is basically, it has different products within the system manager, but we're focusing on system manager, patch manager. So that's actually for automatic patch management, automatic OS update of your S2 instances, or your patch management of your databases, installed on S2, S2 instances. And of course, I am access analyzer. All of these I've mentioned are send findings. So AWS security actually categorize events as findings. So findings is just saying that it categorize them based on what it has been able to access from the AWS config. So AWS config again is an important prerequisite for you to be able to enable AWS security up. So all of these are the send findings. Now, when data are being ingested to AWS Security Hub, you can also send those data from AWS Security Hub to other solutions, other AWS services, or even third-party applications, even to Slack, to ServiceNow, to ticketing systems, Slack and ServiceNow, to BMC Remedy, for them to be able to trigger, say for instance, there is a security logs that are coming from AWS inspector that's now that's been ingested into AWS Security Hub, and you want your ticketing system to be able to pick that up and assign that to the security team. Automatically, you can integrate that security system, example ServiceNow, into the Security Hub to be able to do that for you. Next slide, please. All right, so I don't want to do too much about it because I've already mentioned them during the explanation of the Security Hub. So data, I said Security Hub collects security data across AWS accounts. So it's not just for one account. So when you're building or designing your Security Hub policies, you need to be able to ensure that you want to have it across AWS organization, which is multiple accounts. You want to have it across multiple regions. You can do that as well. You want to have it across AWS services. Supported compliance framework. So AWS Security Hub helps you to comply to a lot of standards. Examples are the likes of PCI DSS, National Institute of Standard and Technology, AWS Fundamental Security Based Practice, which is the proprietary standard for security standard for AWS. Next slide, please. All right, so I already mentioned this again earlier, that AWS security integrates a lot of AWS services and third-party services. So I said that there are two key findings, two key connectors findings. The send findings, which are basically AWS config. I've told you what AWS config is. AWS Health. AWS Health actually monitors the availability of your resources and the services of AWS. So it tells you if a region will be going down, or if there's a performance issue around a region, that's AWS Health. AWS Massive also ingests data as a send findings into AWS Security Hub. So Massive is basically you should check for PII, personalized information, identify information data, which conforms to GDPR. So if you have some data that needs to be secured around confidentiality, the AWS Massive will do that. All of these, are sent findings for AWS Security Hub. Next slide, please. Which is the received findings. So the received findings are basically other services that AWS will send data to for further analysis, for further audit. Examples is AWS Audit Manager, AWS Detective, AWS Trust Advisor. Trust Advisor, of course, collect data from AWS Security Hub and analyze data based on performance, reliability, costs, and the likes. Next slide, please. All right. So in conclusion, so I came in with this statement that security is basically an ongoing effort. So, like I said earlier, from the first time, that security is now an attitude, which means that within for every person in life, you need to continually improve on your attitude. So in this case too, security has to be a continuous effort. It has to be something that disseminates across board, not just within the IT team, not just within the DevOps team, not just within the security team. It has to cut across different business units, all the business units within your organization, down to HR, down to logistics, because everybody can be a victim of security. And lastly, AWS thrives. Like I said, they are constantly, continuously innovating and on security services. That will be all from my side. And I'm open. I'll be happy to answer any questions if you have any. Thank you once again, everyone. All right, should I take questions now? I can see that I have questions from the chat. Did you hear what I said? All right. So okay, so I have a question from Abdul Razak Noebi. When you say data at transit, is it referring to the integrity of data? I mean, ensuring data is secure without being tampered with before getting to it. Exactly. So not just integrity, also the confidentiality of the data. So there's between integrity and confidentiality. The two together has to be protected. You want to ensure that the data is not exposed to someone that is not meant to have that data. That's around the confidentiality. Integrity is about the data is actually the way it was sent. So if I send ABC, by the time it gets to the end user, it's ABC. I hope that answers your question. So it's both for integrity and confidentiality of the data while transferring data from source to destination. Any other questions? Yeah, so because of time, we will not be able to speak about lattice again. I am sure that there will be more time to explain more about lattice. I can drop a link, of course, around that.
Okay, thank you, Samson. Thank you for your time. Thank you for the amazing session we just had. I'm sure everyone enjoyed the session. I actually enjoyed the session. Thank you so much. Thank you for taking time out of your busy schedule to share your wealth of knowledge with us. We really, really appreciate it. And then we hope to be able to get as much certification like you. Thanks certification, just like Mimi said, is no joke. It's no joke. It's just like the common phrase, I want to be like you when I grow up.
No.
Thank you so much. So let's dive into the quiz time. Quiz time, everyone say quiz time. So we'll be sharing the link shortly on the chat. Please look out for the link for you to log into AHA Slides. Yes, fire. It was a great session, Albi. The link, please. So that is the link on the screen, but it will be shared in the chat shortly. So I need everyone who is ready to be the winner for this session. Please. Yes. So that is the link for everyone. I need everyone to join through that link shared via the chat. If you're on LinkedIn, you will get it shortly. So Join in through the link. We're waiting for players to join in. Who will be the first person to join in? I'm waiting for the first person to show up. Guys, let's do this as soon as possible. Join in through the link shared. Let me see the lucky winner at the end of this quiz session. Tundaye and AO came in at the same time. Wow, wow. AO came in with the devil with the devil emoji. Okay, let's see if it's going to take over. Tundaye, Sam's our previous winner. Okay, let's see who's going to win this time. Guys, will you allow Sam to top again? No. We won't. Olix, yes. Waiting for one more person, then we start the quiz. Okay, Azan is in. Please, let's start the quiz. We can start the quiz now. So the question, we have 7 questions. The first question is, which of the AWS service? Oh, something is wrong. We can't see anything on the screen right now. We can't see the AR slides on the screen right now. Okay, we are starting again. 7 question. So the question 1, all but one is a pillar of trust architecture. Okay. Is it identity? Is it infrastructure? Is it physical? Is it application? Is it network? Everyone has answered. Physical. Okay. Who is the lucky winner for this slide? Guys, Psalms. Guys, you need to do more. Psalms again. No. Olix, you can do this. please. Psalms is here to drag this with you guys again. Okay, next question. Fast. The AWS well architecture framework uses on minimizing the environmental impact of running cloud workloads and utilization to minimize required resources. Is it the security pillar, the cost optimization pillar, performance efficiency pillar, reliability pillar, or the sustainability pillar? 3 more seconds to go. Everyone has answered? Okay. Show answer, please. Okay. 2 people got this right. 4 chose efficiency pillar. Okay, let's look at who the winner of this Slide this, please. Sams is not ready to give up, guys. Oleaks, please just give me little more. I'm rooting for you. I'm not rooting for Sams because Sams won in the first session. I'm rooting for you, Oleaks. I'm rooting for you. Okay, the next question, please. All security designs in the cloud except minimize attack surface, automate security, rest, implement continuous security awareness and training, enable traceability. Okay. All security designs. Everyone has answered. Okay, 4 people choose implement continuous security awareness, which is the correct answer. 1 person choose automate security, 1 person choose enable traceability. Now, let's see who the winner are. Even the ass like that, Sam's is rocking the longest streak. Olex, I'm rooting for you. You can do this. You can do this. Okay. Next question, please. I'm short of words, guys. I'm just short of words. Sam's network, every power is working for Sam's at this point. AWS VPC, true or false? Then the maximum VPC a customer can create per region. Select 2 answers that apply to this. Two people are shedding tears. You can do this, guys. You can do this. You got this. You got this, Olix. You got this. I'm rooting for Sam. He's a winner, but he won the first session. So I'm rooting for Olix or whoever is going to overtake Sam. I don't know why, but I am. Everyone has answered. Okay. All right. 5 people correctly. 3 people. Okay. 2 people first. Let's see who the winner is. Oh God. Sam the man. Sam the man. Why is it Sam and Olex like chasing each other like first position, second position, first position, second position? Wow. I'm rooting for you, Olex. We still have about 3 more questions to go. Next question, please. The following are VPC components can be used to secure AWS resources and services, except which one? Is it the security groups? Is it application load balancer? Is it VPC flow logs? Is it the root table? Is it the Amazon inspector? Guys, you can do this. You can do this. You can do this. We are dragging this with Sam the man. We are dragging this with Sam. Everyone, we are dragging this with Sam. And Sam is ready for us. I think he's absolutely ready for us. I don't know why, but Sam is ready for us. It's like You guys don't know. I'm ready for you. And everyone has answered. Okay, let's see what the answer is. Application load balancer, Amazon Inspector. Let's see who the winners are. Da, 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 da. Da, da, da. Why am I not surprised? Oh, leaks. What went wrong at this point? What went wrong? Congratulations, Ayo. Sam, I think you're used to congratulations at this point. So you got it again. Ayo, congratulations on second position. Sam, it's just like we are giving you the award over and over again. Next question. Sam, well done. Well done so far. Well done so far. The following AWS services AWS security automatically except one. Is it the Trust Advisor? Is it AWS configuration? Is it Amazon Inspector? Is it Amazon Mercy, or is it Guard Duty? Which one of it? Everyone has answered. Okay. Trusted Advisor. 3 people got that right. Okay. Let's see who the winner is. Sam? Yeah. Alex! Oh God, Sam, congratulations. Yes, but I'm so glad Oli stopped this. I'm really glad Oli stopped this. Yeah. Who knows? Who knows? The last question, everyone. Sam's. I'm sure you're ready for us for this last question. Yeah. Which of the AWS services is a threat that continuously monitors your AWS account and workload? For malicious attack, discovers detailed security findings for visibility and remediation. Is it AWS configuration? Is it Amazon Inspector? Is it the AWS Trusted Advisor? Is it the Amazon Mercy, or is it the Amazon Guard Duty? Which one is a threat detector? Everyone has answered. Let's see the answer. Wow. Wow, this is quite tricky. Only one person got this right. That gives this person an edge. Who is that one person? Wow, this is quite tricky, guys. Just one person. That means this person has a great edge. Wow. So, guys, this is it. Let's see who the person is. Oh, what happened? Wow. Sams. Congratulations, Sams. Like, congratulations. Wow. So, guys, once again, it's Sam. It's Sam. But, Sam, what do you think? Let's be fair. Olix did well. So I'm thinking, the deal is that we are going to give Olix also this prize because he did so well. Sam, you got the first one. Congratulations on being the winner, but let's give this to Olix. Let's be fair. Let's give this to Olix. He tried so hard. So Sam and Olix, Congratulations, congratulations. I'm like really proud of you. I can't wait to like meet you guys socially. Yes, close call, close call. Sams, you did amazingly well. Like did amazingly well. Please send your details to your LinkedIn profile, because yes, I'm going to check you guys out on LinkedIn. Definitely, I would like to meet Sam. I would like to meet Olix. But for this session, you know that Olix won. Olix is the winner for this session. So we are giving this quiz session to Olix. Congratulations to Olix. Congratulations to Sam for winning the first one. So Olix, kindly send your LinkedIn profile, your email address, your phone number, your Twitter handle to AWS Cloud West Africa at gmail.com. Thank you so much. Thank you so much for doing this with us. I'm really proud of everyone who partook in this. Sam's, I understand you are the winner for this quiz, but you won the first one, so we are trying to be fair. That is why we are giving Olix. You know, it was so close. You said it yourself. Close call. Very, very close. Like you guys were going back to back, and I was rooting for Olix, and you were just saying, no, 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 Tolu, you and Olix, I'm not giving up. And you did it. Congratulations. I would like to meet you via LinkedIn. Sincerely, I would like to meet you. So
Honestly,
yes,
I
you
was
are there,
I was
okay, as
actually
far as you're a
rooting
member
for
of the
Olix
committee.
to win. Honestly, I was rooting for Olix to win, but I think that sounds guy has there is something that guy has. How did he do it?
I
Wow,
said he,
wow,
he
no,
gathered all the
no.
spirits to do this with
This
him.
this was outstanding. Psalms, I know. In fact, I'm surprised because last minute Olix stopped off, and I was
As
thinking Olix was going to maintain that thing. But this Sam's guy is a very smart guy. I don't
mm-hmm.
think I've really met Sam. Sam's, I think I need to know your
No,
real
that's why I
identity.
said I will definitely check him out via LinkedIn. I'll
Yes,
definitely
yes,
check him
yes.
out via
Sam's
LinkedIn.
also send us a good picture of you. Olix also please send us a very nice picture of you. We would like
Mm-hmm.
to celebrate you guys on our page. So congratulations, congratulations once more. Now, guys, we are actually coming to the end of this wonderful session we've had today. Thank you to Sir Elton from AWS, and thank you to Samson Shoeton, who is a project manager and also a a
So,
10 certificates holder. You know, it's not easy now. It's not easy to write exams and pass like this. It's not easy. But do you know the funny thing? Samson has been a longest time friend. I think I know Samson way back in my university days. And to tell you, we were writing CCNA then. Samson will almost get like 1,000 over 1,000. That's how the guy has been right from the days of school. CCNA, CCNP. That's how Samson smashes it. So you see what you see of Samson today, having all those certifications, he did not just start. He has been working a long time ago. And luckily enough, the guy is he's so smart. So Samson Shoeton, we are really happy to have you on the stage today. We are really, really happy. I mean, you have done exceedingly well, amazingly well, and we are grateful for having you on stage. Now, guys, just before you go, we want to let you know of our upcoming sessions. Yes, guys, you heard me right. Upcoming sessions. Now, if you are not aware, we are having a session on Monday. Yes, we are having a session on Monday titled Amazon Inspector for EC2 Security Assessment. Yes, so what I want you to do is I'm going to be sharing the registration link. I want you to go on that page and register. Register for this event because we will be having amazing speakers. I mean, we are having a security expert, Samuel Modupe, who is going to be coming to, to lecture us on this particular topic. And as well, on Tuesday, we are having a beautiful session called Manage Event Resources to Process, Notify, and Take Action in Response to Events on AWS. And of course, who is going to be speaking to us? No other than one of our leaders in the house. His name is Raphael Gabmomo. Yes, Raphael Gabmomo will be taking the second session, which will be happening on Tuesday. I'm also pasting the link here for you guys to go and register. Yes, guys, go and register. Go and register. We want you to benefit from this session. And of course, we are going to be having quizzes after this session. So please do well to pay attention. Do well to, take your jot your notes. Tolu, do you know, I suspect that Sams was writing something when Samson was teaching. I suspect so. Because for him to get all those questions with the way he was doing it, Sams, yeah, I suspect. But I would like to meet you, though. I would like to see you. I mean, I feel like you've done amazing well. So I would like to see you. I would like to meet you. Tolu, what do you have to say to our audience at this point in time for waiting all the while from 10 a.m. to this 1 p.m.? What do you have to say to them?
Guys, thank you for being a part of the community. Without you all joining this session, joining the program, the community wouldn't be as great as this. And then the learning journey does not stop here. That is why we create like all these sessions weekly. We have weekly quizzes that Promise just announced. Please try to attend, especially if you're someone who is trying to transition. I'm always rooting for everyone who wants to transition because that is like a background that I came from. And yes, keep on doing great, keep on being as smart and fast as someone like Sam, Liz, and everyone who participated in the quiz. Like, your learning journey does not stop here. So you took time out of your busy schedule on a Saturday for that matter, when you should have been, in a wedding ceremony, or where you can eat jollof rice and plantain, because that is one of my favorites. So guys, we can always hold each other hands. So please feel free to reach out to any of the community leaders if you have questions. And yes, you will get the slides as far as you're a community member and we have your details, especially your email address. We will definitely contact you for further information. Thank you all. It's nice to meet you all virtually.
Yes, guys. Also, before you go, endeavor to follow our social media channels. Yes, subscribe to us on YouTube. Follow our LinkedIn pages to keep updated with everything, activities, plans we're going to be having for you. Also, we are available on Twitch. We are available on Twitter. All you just need to do is to click on this Linktree link, and then you have all our social media channels. We look forward to having you. And at this time, we want to say thank you for this amazing session. Thank you for listening in. Thank you for paying attention. We are grateful. We are glad to have you here. And at this point in time, we'd like to say thank you once again and bye bye. See you guys. See you guys. See you on Tuesday. I believe that you all will do amazingly well. So well done, guys. Awesome, awesome, awesome.